Hello, hi, namaskar everyone. My name is Deependra and I welcome you all in this one short video of trigonometric functions. In this one short video, we'll cover all the identities, formulae and inequalities based on trigonometric functions and equations, which are used in other chapters, for example, calculus, vectors in 3D, matrices and determinants, and a lot of other places. Don't forget, this chapter is a very simple chapter. You can learn it if you learn all the identities and formulae, and these learnings can be used with other chapters. So remember that along with this free of cost one short video, we are also giving you the DPPs and the handwritten notes at absolutely no cost. You can access this entire material by clicking on the link given in the description, which will redirect you to our TW app. TW app is an amazing platform from where millions of students are already preparing at affordable prices. So let's see what unfolds. So this is all we'll be covering in this one short video. We'll begin with measurement of angles. We'll learn how to convert it into radians. And then of course, we'll talk about the basic identities and trigonometric ratios, some standard trigonometric ratios which you should be aware of. Then we'll start discussing some important or crucial identities which play a very crucial role in your JEE journey. For example, sum and difference formula, multiple angle formula, transformation formulae, and of course trigonometric ratios of multiple and submultiple angles, and then maximum and minimum values of a trigonometric expression, and of course solving trigonometric equations, which is actually excluded from your syllabus, but it is not. Last year only questions were seen from this topic. So yes, this is all what we'll be discussing in this particular one shot video. Now let's get started with the basic thing. Do you understand what is an angle? For example, if I wish to measure the inclination of a line with respect to other line. So if I wish to measure what kind of inclination, at what angle is it inclined? So to measure that inclination, we have introduced the term angle. So let's say this is the initial position and this is the final position of this line. So this final position with respect to this initial position is inclined at a certain angle. Now that angle could be 30 degree, 45 degree, 60 degree, or any angle. So that is how you measure the inclination of a line with respect to other line. So initial and then final position. So final position with respect to initial position is measured, and that's how you measure the angles. Always remember that whenever you measure an angle in the anti-clockwise direction, you read it positively. So whenever you are measuring the angle in the anti-clockwise direction, you read it positively. But let's say this is the initial position, and let's say this is the final position. So from initial to final, if I am measuring the angle, I hope you're realizing from initial to final, I'll have to travel in the clockwise direction. So whenever you measure an angle in the clockwise direction, you always read that angle negatively. For example, here, if the inclination is 45 degree, I'll read it as plus 45 degree. But here, if the inclination is 60 degree, but it was the initial position, this was the final position. So here, I'll read it as minus 60 degree. I hope it is making a lot of sense that it all depends on the direction in which or through which you're measuring that inclination. So that angle will be read either positively or negatively, depending it on, measured either anti-clockwise or clockwise. Did you get that part? There is one more thing that usually the standard format, the standard unit for measurement of angles was degree. We have been discussing this since our childhood. But there is one more unit or one more measurement technique through which you measure the angles. Now, what is that unit? That is radians. Now, what is a radian? If I could simply tell you the conversion between degree and radian, that will be suffice. Along with this, we will also discuss the standard definition of a radian. But even if I simply ask you how to convert a radian into degree, remember this learning that the relationship between the radian and degree is this, that the angle of 180 degree is read as pi radian. So always remember, if degree is not defined on an angle, for example, if I am writing this as 2, so let's say this angle's measurement is 2. So if I am not putting a degree as a unit, then this angle should be read as 2 radians. So usually for radians, we put the sign C here. But if even this sign is not written over here, for example this, then also the by default unit of reading or measuring an angle should be radian, if the degree sign is not present over there. I hope you'll remember this technique, that yes, usually or conventionally or prominently we'll be discussing or we'll be covering angles or we'll be categorizing angles into two categories, degrees and radians. So when you talk about degrees, there will be this degree sign given to you. But when it comes to radian, the sign may not be given to you. So it could be the C sign O given over there, or no sign will be there. So if degree sign is not there, we'll treat the default unit as the radian unit. Now, if I go back to the discussion we were having, please remember. So we have discussed that pi radian is equal to 180 degree. This is something which you must remember. Now, if you have this thing in your mind, will be able to draw a lot of conclusions based on the relationship between degree and radian. How? Let's have a look at that part. Now, if I talk about the conclusion which I'm willing to draw here is that if I talk you or ask you, talk with you or ask about you that what will be the radian conversion of 30 degrees, what will be your response? Sir, we know that 180 degree is pi radian. 180 degree is pi radian. So 180 is 1/6. 180 upon 6 is 30 degree. So 1/6 of pi will be pi by 6. Are you getting it? If you didn't get this part, the very simple conversion which you can use always is that 180 degree we know is pi radian. Did you get this part? Even if this C sign is not present over there, you should treat it as pi radian. This is not degree. I hope you are getting it. For for an angle to be read as in degrees, the unit, if I wish to treat it as a degree here, I should have this degree sign over here. If I'm not having this degree sign over here, I'll be reading this angle in radians only. I hope you're understanding the difference here. Now, we know that 180 degrees pi radian. I want what is 30 degrees. So by that unity rule, can we not get the 30 degrees conversion into radians? I hope that's very simple for you all. That 1 degree will be nothing but what? It will be pi by 180 radian. But what are we asked? We are asked the conversion of 30 degrees, which is very simple for all of us, I believe so, because I hope it will be very simple for you all to say that, sir, if 1 degree is pi by 180 radian, 30 degree will be 30 pi by 180 radian, which when simplified, I hope you all can see very clearly, 30 by 180 is basically 6, 1 by 6 technically, so it should be pi by 6 radian. So it is all up to us whether we write the radian as C here, or if we don't write, then also by default it should be understood that the angle is given in radians. Otherwise, if the angle is given in degrees, they'll use the sign degree. Did you understand this part? Are you able to understand this degree to radian conversion? And similarly, what if I were to ask you radian to degree conversion? Will you not be able to do it? For example, let's say if I ask you what will be the degree value of the angle 3 pi by 4 radian. So 3 pi by 4 is an angle given to me. Of course, no unit is defined, which means it is given in radians. If I'm asking you to convert it into degrees, what will you say? You will say a very simple thing that, sir, pi radian is 180 degree. So replace pi by 180 degree. That's it. Your job will be done. So it will be 3 by 4. Pi means what? 180 degree. So 3 by 4 times of 180 degree. I hope it's very simple and easy for us, because 180 by 4, half of 180 is 90, half of 90 is 45. Triple of 45 is 90 plus 45, which is 35 degree, 135 degrees. So it should be 135 degrees. So are you understanding this conversion both ways, that how do we get radian from degrees and how do we get degrees from radian? Simple link is going to be this, that pi radian is 180 degree. Remember that you will be able to convert any degree into radians, any radians into degrees. Now, what we were discussing was what will be 45 degree. As we have just discussed, 45 degree will be pi by 4, 1/4 of 180 degree. If I were to ask you 60 degree, that will be 1/3 of 180 degree, which should be pi by 3. What is 90 degree? Half of 180 degree, which is pi by 2. So I hope you're realizing we are relating all the angles with 180, and 180 we are replacing by pi to convert it into radians. So that's the simple modus operandi we are supposed to follow. Look at this 180 degree. This is something which you should remember, because on the basis of this only you can convert any data, right, based on this radian to degree conversion. Similarly, 270 degree. So we know 270 is triple of 90, because 9 into 3 is 27. So what is 90? 90 is pi by 2. So triple of 90 will be 3 pi by 2. This is how you can do these conversions intuitively. You need not write all this. You being an ITJ aspirant need not do this much. The more you write, the more time you consume. So try to write as less as possible, so that you can end up saving a lot of time for other important tasks. Now, look at this part, 360 degree, double of 180 degree. 180 degree is pi, so 360 degree will be 2 pi radian. Did you get this part? Did you understand this entire conversion? I hope it was simple. And these conversions should be there at your fingertips. So whenever somebody says or asks, what is 3 pi by 4? You should have this picture in mind that it should be 135 degree. How? Because you should have pi by 4 as 45 degree in your brain. So whenever you have pi by 4 as 45 degree, you can always crack 3 pi by 4. So such conversions can be done very quickly by you, and you should have these at your fingertips. Now, if I move ahead, if I go ahead with these, this is what we know, that if I were to define radian ideally, or as per the definition, it is simply an angle. Please look at this. Is the unit to measure angle, and it does not means that pi stands for 180 degree. No. Pi is a real number, which is an irrational number. I hope you know whose approximate value is 3.14 or 22 by 7. Approximate value. So yes, here pi is a real number. Pi radian is basically 180 degree. I hope you are understanding the difference here. Along with this, yes, do remember that there is one more unit which is great, which is almost obsolete. We deal with these two units, pi radian and 180 degree. That's the most important conversion which you should remember. Of course, here if I were to define radian into angles, if I wish to make you understand that how do you measure radian or how do you define a radian, then the standard definition of a radian will be this, that the angle subtended by an arc of a circle at center which is equal to its radius. What do I mean by that? It's simply this, that let's say there is a circle. Where should I draw it? I'll draw it somewhere here. So let's imagine that there is a circle over here, right? So this is a circle, right? Now in this circle, let's say there I have an arc. I am drawing an arc. So this circle, of course, is having a radius. Let me see the possibility if I could get that. So yes, I can see the center and the radius both. So now in this circle, let's say I could find an arc. Let's say this is an arc, and coincidentally, this arc is having the length same as its radius. Are you getting my statement very clearly? If you were to define the radian, 1 radian, that's what I'm trying to give you here. Let's say this is an arc, and the length of this arc is equal to the radius of the circle. So the angle subtended on the center of the circle, will be given by theta, which is equal to length of the arc divided by radius. So what is the length of the arc? Length of the arc is r. What is the radius of the circle? That is also r. So it is 1 radian. So whenever you divide length of the arc by radius of the circle, you get the angle in radians. Don't assume it to be in degrees. I repeat, whenever you divide the length of the arc by the radius of the circle, you get the angle in radians. Students confuse it with degrees. Do remember that. So yes, if the length of the arc is equal to the radius, I'll get 1 radian. So that's how you can define 1 radian as an angle. Did you understand this whole part? So remember this as a formula. This is something which is very useful. And yes, JEE often or sometimes asks this formula. And do remember it, that length of arc upon radius is angle but in radians, not in degrees. I hope you will remember that result. Now, moving ahead towards some more conclusions, some more important formulae, or rather identities, or rather some values of some standard trigonometric ratios. How I personally remember it, let me share my technique with you. I write 0, 1, 2, 3 and 4 here. And those 0, 1, 2, 3, 4, I divide by 4. So 0 by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. And then I take square root of them. So square root of 0 by 4 will be 0. Square root of 1 by 4 will be 1 by 2. Square root of 2 by 4 will be 1 by root 2. Square root of 3 by 4 will be root 3 by 2. And square root of 4 by 4 will be 1. So that is the technique I follow. 0, 1, 2, 3, 4, divide all of them by 4 and take the square root of them. That will be the standard angle values of sine theta, sine 0, sine 30, sine 45, sine 60 and sine 90. Once you have these values, remember sine and cosine are complementary in terms of angles, which means if sine 0 is 0, cos 0 will also be 0. If sine 30 is 1 by 2, cos 60 will be 1 by 2. If sine 45 is 1 by root 2, cos 45 will also be 1 by root 2. If sine 60 is root 3 by 2, cos 30 will be root 3 by 2. And if sine 90 is 1, cos 90 is also going to be 1. I hope you'll remember it. Along with this, do remember that sine theta upon cos theta is tan theta. So here 0 upon 1 will be 0, which is 10, 0. This 2 and this 2 are cancelled. So 1 by root 3 will be the value of 1030. 1 by root 2 cancels 1 by root 2. So 1045 will be 1. This 2 cancels this 2. So 1060 is going to be root 3. And 1 upon 0 we all know is not defined. So 1090 will be undefined. Are you able to make sense out of it? Now, let us move ahead. We know that these are reciprocal of these angles. So if you take reciprocals of these values can be attained, which is simple to figure out. I hope there is no confusion on that. Now, there are some basic standard three identities which you know very well, which you know already. What are they? I hope you remember. The first of them is sine square a plus cos square is equal to 1. You can prove it by having a right angle triangle. Basically, if you draw a right angle triangle like this, and if you have its, let's say, perpendicular base and hypotenuse, and here you define an angle as theta, so you can define sine theta, cos theta, and tan theta. Even if you don't, you know how to write the Pythagoras theorem. So Pythagoras theorem says that perpendicular square plus base square is equal to hypotenuse square. So if I divide both the sides by hypotenuse square, I'll get sine square a plus cos square is equals to 1. If I divide it by p square, then I'll get the second identity. And if I divide it by b square on both sides, I'll get the third identity. So I hope you are understanding that all these three identities are basically derived from the Pythagoras theorem. The most important task is that you should have these identities at your fingertips. Which one, students? That sine square a plus cos square is always 1. This is an identity. This is true for all the values of a. Similarly, 1 plus tan square a is always sec square a. Always remember it. These identities are very widely used, not just in Trigo, but at other places as well. For example, questions based on integration and questions based on, determinants, matrices, and some other places as well. So do learn these identities. For example, the third one, 1 plus cot square a is always cosec square a. And of course, their variants. What do I mean by their variants? For example, here, if I take tan square a on the right hand side, sec square a minus tan square a will be 1. Here, cosec square a minus cot square a will also be 1. So these are some standard identities which you must have at your fingertips. This is something very basic which is expected out of you, right? If you have learned the basics, what we have discussed so far, this is a very simple question based on what you already know. Can you imagine this? A question asked by JEE Mains in 2025, which may look a very difficult one, but trust me, it is a very simple one. How? Let's have a look at that. So the question says that this is what we need to figure out, the values what we need to figure out, and it is giving you a numerical value. All right, that's fine. And here, this is something we are given that for x, which is between 0 to pi by 2, which means in first quadrant the angle lies, sine x plus sine square x is equal to 1. Okay, what am I given is that sine x plus sine square x is equal to 1. Can I say sine x will be 1 minus sine square x? So sine x can be written as 1 minus sine square x. I can take this sine square x on the right hand side. What is 1 minus sine square x? We know the identity, it is cos square x. So I can write sine x as cos square x. So this is a result which I will remember and I would like to use it somewhere in the question. Along with this, can I draw one more conclusion that if I take 1 cos x here in the denominator, so sin x upon cos x will become tan x. So one more result we are able to create from here, that tan x is equal to cos x. So we have received two results. Sin x is equal to cos square x and tan x is equal to cos x. Right. Now, let's see how can we use or utilize these results over here in this question. So it says cos 12x, tan 12x, which means cos x to the power 12, tan x to the power 12. But I may read it like this sometimes. Okay, I hope you're fine with that. So here, cos x to the power 12. Here I'm given cos x to the power 12. Okay, so I'll write cos x to the power 12, but in a little different manner. So cos x to the power 12, can I not write as cos square x whole raised to the power 6 plus tan x to the power 12. I hope that can be written as tan x to the power 12. But before I write or replace tan x, I write tan x to the power 12. Can I replace tan x by cos x? So that is nothing but what? That is cos x to the power 12. And cos x to the power 12 we have already written as cos square x whole raised to the power 6. So this is cos x to the power 12 plus cos x to the power 12, which means 2 times cos x to the power 12, which can be written as 2 times cos square x whole raised to the power 6. I hope there is no confusion on it. I hope you are understanding what am I doing right now. Similarly, when I proceed further, this is 3. Now 3 times. Please understand again, are you not seeing that we know that as per this question, cos x and tan x are same? So if cos x and tan x are same, I'll say that yes, cos x to the power 10, tan x to the power 10 will be 2 times cos x to the power 10. So I'll be writing it as 2 times cos x to the power 10. And cos x to the power 10 can I not write as cos square x whole raised to the power 5? I hope I can do that. In the same manner, do you not think cos x to the power 8, tan x to the power 8? Again, we know cos x and tan x are same as per this question. So it will be 2 times cos x to the power 8, which I can write as 2 times cos 2 times cos square x whole raised to the power 4. I hope there is no confusion on that. You have a great clarity so far. Plus, what do I have next? I hope I'm not making any errors. This was 3 times of it. Yes, I hope we are going right. Now, plus, we have next, which is cos x to the power 6, tan x to the power 6. So it should be 2 times cos x to the power 6. So it should be 2 times cos square x to the power 3. Did you get it? How did I do it and why did I do it? So it should be cos square x cube. I hope you're getting it very clearly. Now, one more conclusion we have, which is that cos square x is equal to sin x. So all these cos square x, I'm willing to replace by sin x. I hope that's fine. That is worth doing. So let's do that. So here, what am I getting? It is 2 times cos square x I'm replacing by sin x. So it is sin x to the power 6. Did you get this part? It is sin x to the power 6. Plus, this is 3 times. This is 3 times. What do I have here? I'll be having cos square x to the power 5. What is cos square x sin x? So it should be, can I take this 2 common from outside? So this 2, 2, 2 and 2, I am taking outside. So I have taken that 2 outside. I hope it's fine. It's absolutely fine. This 2, this 2, this 2 and this 2, I am taking common. So what am I left with? Cos square x to the power 6, which is sin x to the power 6. This is 3 times. Cos square x I can replace by sin x. So this is sin x to the power 5 plus this is sin x to the power 4. I hope you are comfortably understanding this. No confusions on that. Everyone with me so far. Plus, of course, what do I have next? I am having cos square x is sin x. So this is sin x cube. I hope there is no doubt, confusion or hesitation on that front. You're able to understand all of this completely and clearly. What I'm doing next is, can I say that let's take something common from here? Why? Because I am seeing an identity getting created. Are you seeing that? If you are not seeing that, let me show you here. Please pay attention. I will try to show you here. What is it going to be? See, it is sin to the power 6x, right? So we have this 2. Let's have this. Let's keep this 2 outside. What about this? Sin x to the power 6. Can I write it as sin square x whole raised to the power 6? I hope we can do that. Sin square x whole raised to the power, it's not 6, I'm really sorry, it should be 3. Yes, so this sin square x whole raised to the power 3 will be sin x to the power 6. Did you get that part? Now, from here and here, let me write this part first. This is what? Sin x cube. Okay, I'll keep it like this only. So this is sin x cube. So I'll write it like this, sin x cube. So what I am seeing or getting created is a cube plus b cube. So I may see 3a square b plus 3ab square. Are you getting the logic? A plus b whole cube I might possibly see. So here, this is a sin square x and this is b sin x. So can I see 3ab? So 3ab will be what? Sin to the power 4x if I take common. If I am taking sin to the power 4x common from here, what will I see? If I take sin to the power 4x from common here, it will be sin x plus 1. Okay, so this is 3 already. So now I am having 3 times sin to the power 4x, which I'm writing as sin cube x into sin x. I hope I can write sin to the power 4x like this. Into what do I have here? Into I have sin x plus 1. So this is what I am left with. What am I left with? I am left with sin x plus 1. So this is how I'm writing all of this. Now I am asking you to pay attention to what we have been able to create here. Are you not able to notice? It is a cube plus b cube plus 3ab times whole of a plus b, which is a plus b whole cube. So will I not write it as 2 times a plus b whole cube? It is going to be sin square x plus 1 whole cube. Did you understand this entire result? Are you able to understand this completely and clearly? Any confusions on that? This is your a plus b. Sorry, b is not 1. I'm really sorry for that. I think I am making an error here because it should have been sin square x whole cube. I think there is something wrong here. Let me just cross check it once again. So it is sine x to the power 6, which we have written as sine square x whole raised to the power 3. Sine to the power 4x I have taken common. Instead of sine to the power 4x, what if I take sine cube x common? So if I take sine cube x common, yes, I'm really sorry. I have made an error here. To make it look like this. Yes, mistakenly I have taken sine to the power 4x common. I should have taken sine cube x common. I hope you must be realizing why. So from here, if I take sine cube x common, I'm really sorry for that wrong impression we have created there of the identity. Let's create the right impression. So here, from here, I'll be taking sine cube x. Although sine to the power 4x can be taken common, but instead I'll deliberately will take sine cube x common. So this will be 3 sine cube x. And that sine cube x I'm writing as sine square x into sine x. I hope you understood why. Because A, B. I don't know why did I not see that. Okay, leave that. So sine cube x when taken common, you are now left with here, you're left with sine square x, and here you're left with sine x. Now that does our job. So it is going to be sine square x into plus sine x. I hope there is no confusion on it. Now it looks fine because see, sine cube x into sine square x will be sine to the power 5x. Sine cube x into sine x will be sine to the power 4x. That's exactly what we have here. And that is sine cube x. Now it is the identity because it is a cube plus b cube plus 3ab times a plus b. I hope it is perfectly fine. So it should be a plus b whole cube. What is going to be the value of a plus b whole cube? So a plus b. What is b? B is sine x whole cube. Everyone comfortable with this? I hope there is no confusion on this part and you are getting this very clearly. It is sine square x plus sine x is equal to 3. I hope we are going great with that. Now, moving ahead, what do I have next? Can I write this sine square x as 1 minus cos square x? So here, I am writing this as 2 times. Sine square x I'm replacing by 1 minus cos square x plus sine x is equal to what? Is equal to 3. Everyone with me? I hope there is no confusion on it. Now, we know that cos square x and sin x are equal. So if I could replace cos square x by sin x, I hope you're realizing this sin x and sin x are cancelled because sin x and cos square x are equal, which means sin x minus cos square x will be 0. So what am I left with? 1 cube. So outside we have 2 and 2 into 1 cube will be 2. So the final answer to this question will be 2, option D. Did you understand how did we solve it and what was the approach we were using? I didn't do anything special. All I did was simply used the identity. And by looking at this identity, we all could crack it. And the only part here which was tricky was to convert into the identity, which we have learnt in the quadratic equations only, where we have learnt that a cube plus b cube plus 3ab times whole of a plus b is always a plus b whole raised to the power 3. Do you remember this as a result? We have had a discussion on this. Now, moving ahead towards the next set of formulae or identities or graphs, here we'll be discussing how do they look like. Although we had a discussion about this in the chapter functions as well, but here also we'll seek more clarity so that we can get or draw few more conclusions. Now, if you look at the graph of sin x, you will always see that it passes through 0. And on the x-axis, it will pass through, it will always intersect the x-axis at all the multiples of pi. So at pi, 2 pi, 3 pi, minus 2 pi, you will see the graph of sin x intersecting the x-axis. Along with this, what you will also notice is that sin x attains its maximum value as minimum value as minus 1 and maximum value as 1. Not just that, it acquires its negative value. If I look at this interval only, minus pi by 2, pi by 2. So at minus pi by 2, it becomes minus 1. And at pi by 2, it becomes 1. So this is the curvature it follows. I hope you can see its curvature. So few generalizations if I were to give you. Its graph exists from minus infinity to infinity. So its domain will be all the real numbers. But it takes all the values between minus 1 and 1 only. So I hope you can see the graph always ranges between minus 1 and 1 only. That's where I say, or I'll say that its range is minus 1 to 1. Since it is a periodic function, I hope you know that what do you mean by periodic function. So this is the period of the trigonometric function sin x, because this is the curve which keeps on repeating itself. The same curve you'll pick and then drop from 2 pi to 4 pi. The same curve will hold from minus 2 pi to 0. So 2 pi is the period which keeps on repeating through which it keeps on repeating itself. Along with this, few more conclusions which you could draw, that here at pi by 2 it was 1, then it was 1 at 5 pi by 2. If I look at minus 1, then it was minus 1 at minus pi by 2, then 3 pi by 2. So I hope you're realizing at all the odd multiples of pi by 2, which are of the category 4n plus 1, it will be 1 sin x. And at all the odd multiples of pi by 2, which are of the category 4n minus 1, it will be minus 1, the sin x. I hope these conclusions you can draw through the graph of sin x. So remember the graph of sin x, you should have this picture in your brain. And whenever you see sin x, you should be able to draw these conclusions which we have discussed. Not just that, let's look at the graph of cos x. Now, if you shift the graph of cos x by pi by 2 on the x-axis, then you will see if you shift the graph of sin x by pi by 2, then you will see the graph of cos x. How? See, what I did was, previously, the sin x graph was passing through 0 and then it was going like this. But here, if I shift it on the x-axis, on the left-hand side, towards the left-hand side, so what I'm seeing is the graph of cos x being formed. Now, what are the challenges or observations I'm making here? Please look at this part. Cos x also has a range from minus infinity to infinity, because I can see its graph lying through x-axis everywhere, or passing through x-axis everywhere. Yes. Now, if somebody asks me, when do you see cos x becoming 0? I'll say, sir, cos x becomes 0 whenever the angle is an odd multiple of pi by 2. So minus pi by 2, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 will be the odd multiples of pi by 2, and at those angles, cos x will become 0. Along with this, if I look at the multiples of pi, so pi, 2 pi, 3 pi, 4 pi, these are the values, or these are the angles where cos x will be either minus 1 or 1. I hope you can see, at odd multiples of pi, it will be minus 1. At even multiples of pi, it will be plus 1. So these are some simple observations which we all can make quite easily. Not just that, along with this, you should remember that the range of this function is minus 1 to 1, as we have already discussed. This is also a periodic function, because look at this graph. Look at this graph from 0 to 2 pi. Look at the chunk of the graph from 0 to 2 pi. The same chunk is repeated from 2 pi to 4 pi, 4 pi to 6 pi, and then 6 pi to 8 pi, or even from minus 2 pi to 0, like that. So it is again a periodic function. All the trigonometric ratios are periodic in nature. Now, let's talk about the function 10. Before I discuss 10, I hope you have gotten a great clarity on this. What if I ask you, when does it become 0? It becomes 0 at all the odd multiples of pi by 2, and it becomes 1 at all the even multiples of pi, and it becomes minus 1 at all the odd multiples of pi. I hope you will remember that. Now, let's talk about the graph of tan theta or tan x. So this is the curvature which tan x follows, and it is again a periodic function, but this time the function tan x has a period pi. See, from minus pi by 2, I can see its graph, but the graph breaks at pi by 2, and then again from pi by 2, 3 pi by 2, I can see the existence of the graph. So I will say its domain is all the real numbers except for all the odd multiples of pi by 2, because at pi by 2, 3 pi by 2, 5 pi by 2, tan x doesn't exist. Do you know that? Because cos x becomes 0. Not just that, it is an increasing function. Between minus pi by 2 to pi by 2, it is increasing. Then again, between pi by 2 to 3 pi by 2, it is increasing. So it is an increasing function between these smaller chunks. Along with this, if I were to ask you its range, you would say, sir, graph of it can be seen from minus infinity to infinity. And yes, its range is going to be all the real numbers. On the y-axis, it does not break. You can see it very clearly. Along with this, what you can also notice is that, sir, what other things you are seeing? One more thing I'm seeing is that it is becoming 0 at 0. At pi, it is becoming 0. So at all the multiples of pi, it will become 0, because tan x is sin x upon cos x. So whenever sin x becomes 0, tan x will also become 0. I hope you're realizing why. So 0, pi, 2 pi, 3 pi, 4 pi, these are the points where tan x will be becoming 0. Along with this, few more conclusions. I think this is all about tan x. Did you get that part? I hope there is no confusion on that. Now, let's talk about the graph of cot x. What is cot x? Reciprocal of tan x, 1 upon tan x. So I'll be seeing it getting, inverted like this. So if tan x was like, this between 0 to pi, cot x will be like this and this between if tan x was like this between minus pi by 2, cot x will be like this and this between minus pi by 2 to pi by 2. I hope you're understanding the conclusion why. Because it is reciprocal here. I hope you're understanding what do I mean by being reciprocal. Along with this, again you can see, one more thing I forgot. 10x is a periodic function which has the period pi. 10x is a periodic function which has the period pi. Similarly, cot x is also a periodic function which has the period pi. You can see it here. This is clearly a periodic function with a period pi. Can you not notice it here? Not just that, now you should remember cot x is reciprocal of 10x, which means cot x should be cos x upon sin x. So whenever cos x becomes 0, cot x will also become 0. So at all the odd multiples of pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, at all these points cot x will be becoming 0. And whenever sin x becomes 0, cot x will be not defined because it is cos x upon sin x. So at all the multiples of pi, for example 0, pi, 2 pi, cot x will be not defined. And in these simpler chunks, 0 to pi, pi to 2 pi, 2 pi to 3 pi, what we were seeing is that 10x was an increasing function in these smaller chunks. And you must see that cot x will be a decreasing function. Because what is cot x? 1 upon 10x. So if 10x was increasing, cot x will be decreasing. I hope you're getting it very clearly. And of course, if I again talk about its domain, it will be all the real numbers except for multiples of pi, because there cot x is not defined. If I talk about its range, you won't hesitate in saying, sir, we can see its range from minus infinity to infinity, all the real numbers. Again, a periodic function with period pi. Are you able to make some sense out of it? Now let's talk about another interesting function, sec x. To understand sec x, I'll try and make you understand the graph of cos x. Once you understand the graph of cos x, you will be in a better position to draw it. I'll try and draw the graph of cos x. So we know from minus pi by 2 to pi by 2, graph of cos x looks like this. Then from pi by 2 to 3 pi by 2, graph of cos x goes like this. From 3 by 2 to 5 by 2, the graph of cos x goes like this. So this graph I have drawn as the graph of cos x. Now what is sec x? Sir, sec x is reciprocal of cos x. Sec x is reciprocal of cos x. So whenever cos x is 1, sec x will also be 1. Whenever cos x is minus 1, sec x will also be minus 1. But since it is the reciprocal, then if cos x was between 0 to 1, do you not think 1 upon cos x, which is sec x, will be from 1 to infinity? Are you getting my point very clearly? Whenever cos x becomes 0, that is at pi by 2 and minus pi by 2, something like that, at those points sec x will be not defined. Are you understanding this phenomenon as well? Similarly, whenever cos x was between 0 and minus 1, whenever cos x was lying between minus 1 and 0, sec x, that is 1 upon cos x, will be between minus infinity to minus 1. And of course, again at pi by 2 and 3 pi by 2, since cos x was 0, sec x will be not defined because it is a reciprocal of cos x. So are you understanding all these conclusions which I am drawing with the help of the graph of cos x, which you can remember? So this is how you draw the graph of sec x. Again, it is basically inverted. And in the same fashion, you can draw the graph of cosec x as well. But before I move to cosec x, I hope you'll remember that sec x is also a periodic function which has the period 2 pi. Because I hope you can see that this, and this was there from 0 to 2 pi. The same can be seen from 2 pi to 4 pi and so on. I hope there is no confusion on that. Along with this, what you should remember is its range and domain. So if I talk about its domain, its domain is all the real numbers except for the points when cos x becomes 0. So whenever cos x becomes 0, sec x goes not defined. And at those points, sec x will not exist. I hope you're realizing that. What about its range? I hope you remember cos x was between minus 1 to 1. So sec x will be reciprocal of it, which means it will have values from minus infinity to minus 1 and 1 to infinity. Did you get that? Did you understand this process completely? Now, if you have understood the graph of sec x, now let's talk about cosec x. The same logic can be used. See, how do we see the graph of sin x? So this is how you draw the graph of sin x. So this is how the graph of sin x is drawn. Do you remember that? Now, what change do we see in cosec x? It is again same as sec x only. You just shift it pi by 2 on the right hand side on the x-axis. I hope you can see between 0 to pi, sin x is between 0 to 1. So between 0 to pi, cosec x will be between 1 to infinity. Are you seeing it? And at 0 and pi, sin x becomes 0. So at 0 and pi, cos x will be not defined. Cosec x will be not defined. Similarly, between pi to 2 pi, sin x is between minus 1 to 0. So between pi to 2 pi, cosec x will be between minus infinity to minus 1. And yes, at pi and 2 pi, sin x was 0. So cosec x will be not defined. So I hope you are understanding how can we draw the graph of cosec x based on the graph of sin x. Yes, here also we can draw these conclusions that if I were to talk about the range, its domain first of all will be r minus n pi. All the multiples of pi should be excluded because there sin x becomes 0, and that's why cosec x will be not defined. If I talk about its range again, since sin x lies between -1 and 1, its reciprocal will be either less than -1 or greater than 1. So same is being done here. And when you talk about its period, that is again a periodic function with the period 2 pi. I hope there is no confusion on it and you have understood all these 6 graphs. I will always insist and emphasize and urge that you should have these graphs in your brain. Minimum sin x, cos x, tan x should be there at your fingertips. And of course, you should be able to draw the graph of scotec x, cot x, cosec x, and sec x. Because with the help of these graphs, we will be understanding the chapter inverse trigonometric functions. So the better you want to get with the concept or chapter ITF, you should be more clearer with these graphs and the concepts of trigonometric functions. The better clarity you have here, the more easily you will be able to handle the next chapter ITF. I hope you're understanding the reason. And yes, to do that, you should have this understanding with you. Now, one more thing is there. If I were to compare the graph of sin x, tan x, and y is equals to x. So I'll just draw 3 lines. I'll use yellow color for sin x, the graph of sin x. So I'm drawing the graph of sin x here. So this is how you draw the graph of sin x. This yellow colored line is showing you the graph of sin x. So this is the graph of sin x. I hope there is no confusion on it. Sir, why are you doing it? Trust me, you need to remember the result which I'm going to show. Once I have shown this particular result, I'll tell you how is it useful and at what all other places you can use it. So first of all, have patience and let me show you these 3 graphs together, sin x, tan x, and x. Please pay attention to this part. Now the next graph which I'm going to draw is going to be y is equals to x. So y is equals to x is pretty simple. We all can draw it here like this. So I'll start with this line over here. I'll start with this line over here. So this line goes like this and it reaches here. So this here is the graph of y is equals to x. This is the straight line, y is equals to x. Don't forget that. Similarly, what about this straight line with the yellow color? This was the graph of y is equals to sin x. Now, the other part which is already drawn with white color, so I need not put efforts on it. That graph is shown by 10x. Which part, students? I hope I need not explain this part. This graph over here is shown by white line is the graph of 10x. I want you to pay attention between this particular range. Which range, students? Minus pi by 2 to pi by 2. Look at this specific zone. This is the most crucial zone where I want you all to have or pay attention to. So this is the zone where I want you all to pay a lot of attention. Look at this particular part. Just give me a second. I'll just draw it more clearly so that, okay, leave it. So now, look at this box, this particular box which I have drawn over here. Between minus pi by 2 to pi by 2, I hope you're realizing as soon as you start getting closer, to 0, the moment you start getting closer to 0, do you see that all of them are overlapping? So x, sin x and tan x are equal if x is very small. So remember, the moment you see x approaching 0, the moment you see limit x approaching 0, what do I mean by x approaching 0? It means when you start reaching 0 towards both the sides, left hand side and right hand side, then you start seeing that whether you see sin x or whether you see x or whether you see tan x, all of them become almost equal. For example, if I look at this value, this very close value of 0, I hope you can see this part here. At this point, all of them are very close and they are equal. So the more you reach closer towards 0, sin x, x and tan x are equal. They take approximately equal values. They overlap each other. The graphs, I hope you can see, are clearly depicting this particular part. Not just that, after this particular part, on the right hand side of this, you will start seeing till let's say 0.5 pi, which is pi by 2, you will start seeing that tan x is greater, which is greater than x, which is greater than sin x. So sin x is smaller than x, which is smaller than tan x. But here, if you pay attention, then between pi by 2 to 0, of course, close to 0 it will be equal, but between minus pi by 2 to 0, sin x will be having an upper hand. It will be greater than x and it will be greater than 10x. So do remember these results, or at least this graph. I would request that you take the screenshot of it so that you keep this particular image with yourself and have this image in your brain that this is how the graph of sin x is drawn. This is how you draw the graph of 10x, and somewhere in between the graph of y is equals to x passes like this. So when values are approaching 0 on the x-axis, they will become equal, x, 10x and sin x. And that's why limit sin x upon x, 10x upon x is 1, because they are equal. I hope you're understanding it. Whenever x approaches 0. But if you move towards the left hand side and if you move towards the right hand side, this is the relation that 10x greater than sin x. And on the left hand side here, between minus pi by 2 to pi by 2, sin x is greater than x is greater than 10x. Do remember this as a result. It will be very helpful in solving questions based on limits, continuity, differentiability, even in definite integration, even in drawing the graphs, even in definite integration, even under the chapter area under the curve. At a lot of places, this particular phenomena or concept or graph or understanding is very, 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 very useful. Please remember that. Don't forget that. Now, let me get back to the discussion we were having. I hope you have had a great understanding on this particular part, that how do you relate 10x, sin x and x. Now, this is something which you should remember. If you don't, let me try and make you understand through a very simple part. Let's say I have these quadrants. Let's say I have these quadrants, right? So these 4 quadrants I have drawn. So this is the y-axis, let's say. All right. And here you have the x-axis like this, let's say. So this is the x-axis, let's say. I hope there is no confusion on that. Now, if I have y-axis and x-axis going like this, of course, let's say this is 0 radian or 0 degree. From 0, I move 90 degree anti-clockwise. So this will be 90 degree. 90 degree I can call as pi by 2. From pi by 2, again I move anti-clockwise. So this will be pi. From pi, if I again move anti-clockwise 90 degrees or pi by 2, then this will be pi plus pi by 2, which is 3 pi by 2. Then 3 pi by 2 plus pi by 2 will be 2 pi. 2 pi plus pi by 2 will be 5 pi by 2. 5 pi by 2 plus pi by 2 will be, of course, 6 pi by 2, which is 3 pi. Then this will be, I hope you must have started noticing the pattern. You must be seeing very clearly that this will be 7 pi by 2. Then here again, it will be 4 pi. So if I were to generalize, what I'm seeing right there is that if I keep rotating, because it is an endless loop. Even if I could have moved in the clockwise direction as well, 0, minus pi by 2, minus pi, minus 3 pi by 2, and so on like that. The conclusion which I'm trying to give you here is that all the angles which I'll be seeing on the positive side of x-axis will be even multiples of pi. So I can generalize them as 2n pi, where n is going to be a integer. Here, if I look at this negative side of x-axis, I am seeing the odd multiples of pi, which means 2n plus 1 pi or 2n minus 1 pi, whatever you wish to write. Now, here, these and these on the y-axis, positive and negative, they are the odd multiples of pi by 2. But to be more specific, 1, 5, I hope you can see these are 1 more than any multiple of 4, which means what? They are of the 4n plus 1 category of multiple of pi by 2, which means if you keep replacing 1, 2, 3, 4 here, then these number will be any multiple of 4 more than 1 than that, which means 4n plus 1, 1 more than any multiple of 4, which means 1, then of course you had what, 5, then you'll have 9, then you'll have something like that. And here if you pay attention, they are 1 less than the any multiple of 4. I hope you can see 3, 7. So 4 minus 1, 3, 8 minus 1 is 7, 12 minus 1 is 11. So something like that you'll see here. So which can be generalized as 4 minus 1 times pi by 2. First of all, are you seeing these generalizations? Now, why am I showing these generalizations? Since we have seen or understood or learned that all the graphs are periodic. So when you start noticing their graphs, they start showing you a pattern. They start showing you a generalization. And that generalization we can do through this quadrant theory only. So I'm giving you a cheat sheet, I'm giving you a quadrant theory on the basis of which you can draw or figure out any angle. How? Let's have a look at that. See, in the first quadrant, we'll say all the ratios are positive. For the second quadrant, I'll say sine and its reciprocal, which is cosec, are positive. In the third quadrant, we'll say tan and cot are positive. And for the fourth quadrant, we'll say cos and its reciprocal sec are positive. So what is the advantage of this? One more thing you should remember, whenever you move from the x-axis, that is upward or downward, the ratio doesn't change. But if you are moving from the y-axis, left or right, then the ratio changes. And this changing of ratio happens in this manner. In which manner, students? The changing of ratio with respect to y-axis happens in this manner, that sin x becomes cos x and vice versa. Cos x becomes sin x. Tan x becomes cot x and vice versa. Cot x becomes tan x. And sec x becomes cosec x and vice versa. Cosec x becomes sec x. What do I mean by that? I'll take some examples and make you understand this. Let's say I have an angle where I'm writing cos 3 pi plus pi by 3. Now, identify the quadrant. What do I mean by 3 pi? I hope you can see 3 pi is here. When 3 pi plus pi by 3 is done, you are moved into third quadrant. Now, in the third quadrant, first conclusion will be that in the third quadrant, tan and cot are positive, which means cos is going to be negative. So I'll put a negative sign here. Now, look at this part, this 3 pi. Is it on the x-axis or y-axis? So 3 pi is on the x-axis. As we have discussed, on the x-axis, ratios don't change. So this will still remain as cos x, and here it will be cos this angle, which is pi by 3. This is what I'm trying to make you understand. I'll try to give you more clarity. For example, let's say if I were to ask you sine 5 pi by 2 minus, let's say, pi by 4. This is the value I wish to figure out. How do I do it? See, first of all, identify where is 5 pi by 2. So I think 5 pi by 2 is here. This is 5 pi by 2. 5 pi by 2 minus. So if I'm subtracting, I'm going back to the first quadrant. In the first quadrant, what is it? In the first quadrant, all are positive. So I'll be using a positive sign. So I need not write any sign which is positive basically. Now, sine 5 pi by 2. Where do I see 5 pi by 2? On the x-axis or y-axis? Sir, on the y-axis. So if it is on the y-axis, if I'm subtracting it, then I'm moving it in the first quadrant. But since it is on the y-axis, and if you are on the y-axis, if you are going left to right from the y-axis, then the ratios change. So sin x becomes cos x. If sin x becomes cos x, I'll be writing it as cos pi by 4. Are you understanding these conversions? Which means if you know the standard values, if you know the basic values, you can figure out any standard angle periodically, if given periodically. Are you understanding this? Let's take two more examples. Let's say I'm writing 10, 99 pi minus, let's say, pi by 6. What will you do here? Now, you need to crack where does 99 pi lie. So, 99 pi, which means odd multiple of pi. As we have cracked, odd multiples of pi lie here. So this is the point where I'm placed right now. Now, after this, I am subtracting something from it. So from negative x-axis, if I'm subtracting something, I'm moving to the second quadrant. So what happens in the second quadrant? So in the second quadrant, sine and cosec are positive. But what is it? It is 10. So it should be negative. So it should be negative. Now, 99 pi, is it on y-axis or x-axis? Sir, it is negative x-axis. Will the ratio change? No. So if the ratio doesn't change, it will be 10 of this value, which is pi by 6. This is a standard cheat sheet which you should learn, memorize and follow at this stage. Logical explanation I won't be giving in this one shot. I'll simply tell you that they are periodic in nature. That's why such conclusions can be drawn. So remember the fact, remember the standard operating procedure, what we are doing, and follow it blindly. Have faith in your teacher. Similarly, let's take one more example. Let's say I take sec any angle. Let's say I'm taking, let's say 102 pi minus, let's say, minus or plus, let's say, pi by 4. Now, what do we see from here? 102 pi. 102 pi is an even multiple of pi, 102, which means I'm placed here. Plus pi by 4. I hope you can see plus pi by 4 means what? From here, I'm moving to first quadrant. The best advantage of having the first quadrant is all are positive. So I need not bother about the sign. The signature will be positive. See, sec, and we are lying on which axis? We are lying on the x-axis, and because of x-axis the ratios don't change. Had it been an odd multiple of pi by 2, I would have to convert sec x into cosec x, but here since 102 pi is on the x-axis, this ratio wouldn't change, and hence it will be sec pi by 4. So are you able to understand how are we doing it? And are you able to make some sense out of it? And if you have gotten it, let us understand all of what we have learned so far through this simple, straightforward example. What does it say? It tells you that sin x is sin x is minus 3 by 5. We are already told this value. We are already given this value. And x is between pi to 3 pi by 2. Now, if I simply could draw the quadrants, this is where you have this pi and this is where you have 3 pi by 2. So we can see that this angle x is in the third quadrant. This angle x is in the third quadrant. We all know that in the third quadrant, which ones are positive? Tan x and cot x. So this image you should have in your mind the moment you see that x is between pi and 3 pi by 2. Did you get this result? Now, let's talk about the next part. Which part, students? 80 times tan square x minus cos x is equal to. Okay, let me draw a right angle triangle which has, let's say, an angle x. Let's forget this minus 3 by 5 as of now. Let's treat the ratio as 3:5. So what is sine theta? Sir, sine theta is perpendicular upon hypotenuse. So perpendicular will be 3, hypotenuse will be 5. We know the Pythagorean triplet. It says that this will be 4. I'll decide their signs accordingly. That I need not worry about. But 3, 4, 5 will be the proportionality coefficient here. So 3k, 4k, 5k, that will be the value. Of course, signature will keep on varying. That I'll decide from here. Now, let's say I need to deal with tan x. Although it is tan square x, I need not deal with sine because tan square x will make it positive. But let's say still I wish to write to make you understand what will be the value of tan x. So what will be the value of tan x? See, in the third quadrant, tan x is going to be perpendicular upon base, which is 3 by 4. And for the third quadrant here, whatever x is going to be, tan x is going to be positive. So yes, tan square x we wish to write, or tan x, it is going to be 3 by 4 whole. What's wrong with this? 3 by 4 whole square. Did you get this part? Minus cos x. Now, when I wish to write cos x is going to be base upon hypotenuse, which is going to be 4 by 5. But x is in the third quadrant. X is an angle which lies in the third quadrant. In the third quadrant, cos x is negative. So it should not be 4 by 5. It should be minus 4 by 5. It should be minus 4 by 5. Did you get that part here, students, very clearly? And this all should be multiplied by 80. Did you understand how did I do it, or shall I re-explain this part? How did I find tan x? How did I find cos x? More importantly, how did I decide their signature after deciding that in which quadrant do they lie? So if you get this clarity, on the basis of this only, you can say a lot about the other ratios through this simple Pythagoras theorem. Now, and of course, based on this quadrant theory as well, which will help you in deciding the signature as well. Now, let me get back to this part. I hope the calculation is something which you all can do very easily. What is it going to be? 3 square by 4 is going to be 9 by 16. And this is going to be 4 by 5. I hope it's a very simple task. You all are comfortable in doing that. So here, if I could simply do that, 9 into 5 is going to be 45 plus 16 into 4 is going to be 64. I hope there is no hesitation or doubt in that. Divided by 16 into 5, which is 80. 80 gets cancelled by this 80. So 45 plus 64 should be how much? 5 and 4, 9. 4 and 6 are 10. So 109 should be the correct option. Option B. Did you understand the whole process? Did you understand the entire calculation? And are you realizing if you know this quadrant theory, then you can crack such questions so easily? And that's what this exam is all about. The better you are conceptually, the easily you will be able, with more ease, you will be able to solve these category of questions. So I hope so far, no doubts, no queries, no concerns are there. Let us move ahead and let us start understanding some important identities, right? Now we move towards the part where we'll be discussing a lot of identities which are used at a lot of places. Of course, we'll begin with the basic, the simplest one, which says sine A plus B. Now, what is sine A plus B? Remember, sine A plus B, here you need to understand that it is not sine A plus sine B. I hope that is something very simple and easy, which should be understood by you all. It is sine of whole of A plus B. So it should be treated as sin A cos B plus cos A sin B. Of course, it has its own proof, which will not be discussing in this particular video. But this is something which you should remember on which questions are framed and asked. And of course, if I were to use sin A minus B, then it will be sin A cos B minus cos A sin B. Similarly, there is this next identity, which is cos A plus B. So this formula says cos A cos B minus sin A sin B. So if I were to ask you cos A minus B, you would say cos A cos B plus sin A sin B. I hope that is understood by you all. Similarly, if I am having 10A plus B, it will be 10A plus 10B upon 1 minus 10A 10B. Similarly, if I say 10A minus B, you would say 10A minus 10B upon 1 plus 10A 10B. I hope these three very standard, very basic formulae you will remember, based on which let's try and solve a question. What does it say? The question says cot alpha is given as 1, sec beta is given as minus 5 by 3. We are also given that alpha is between pi and 3 pi by 2. So I hope you can say a lot about alpha. You can say a lot about beta as well. Beta is between pi by 2 and pi. All right. Then you are asked the value of 10 alpha plus beta. Great. Now, if I'm asked the value of 10 alpha plus beta, what I know? Sir, if somebody says do write 10 alpha plus beta, I'll say it is going to be 10 alpha plus 10 beta whole divided by 1 minus 10 alpha 10 beta. But the problem is, do I know the values of 10 alpha and 10 beta? Let's try and figure them out. Here, when you say that cot alpha is 1, when somebody says cot alpha is 1, then I won't hesitate in saying that 10 alpha will be 1 upon cot alpha. If cot alpha is 1, you can unhesitatingly say that 10 alpha will also be 1. Did you get that part? I hope there is no confusion on that. Now, let's come and talk about this part, sec beta. Sec beta is said to be minus 5 by 3. Minus 5 by 3. And what is beta? Beta lies between pi by 2 to pi. Can you help me with pi by 2 and pi? I hope you remember pi by 2 is here, pi is here. So pi by 2 to pi means which quadrant? Second quadrant. In second quadrant, we know which one is positive. In second quadrant, if I were to talk about, then in second quadrant, we know sine and its reciprocal cosec are found to be positive. So sine and cosec are positive. So of course, in the second quadrant, 10 is going to be negative. So 10 beta, whatever value I'm going to get will be negative. So whatever value of 10 beta I'm going to get will be negative. That is the conclusion for sure I have drawn. But if I look at this beta, what is sec? If I look at this ratio part only, 5 and 3. So sec is hypotenuse upon base. So if base is 3, hypotenuse must have been 5, which means perpendicular must have been 4. I hope no confusion on that. If I were to ask you the value of 10 beta, so numerically you would say, sir, 10 beta will be perpendicular upon base, which is 4 upon 3. But with the sign, if I were to put a comment on it, sir, 10 beta lies in the second quadrant, and in the second quadrant, 10 ratio is found to be negative, and that's why it should be minus 4 by 3. Are you understanding this whole process, this entire method? So we had a 10 alpha, we have 10 beta. I think we can put the values and get the answer. Did you understand? This is how simple questions are if you know the formula, if you know the funding. So here, I'll say 10 alpha. What is 10 alpha, students? We have cracked 10 alpha, which is 1. Plus 10 beta. What is 10 beta? That is clearly minus 4 by 3. Now let's put more comment on the data, which is 1 minus 10 alpha. What was 10 alpha? It was 1. And then 10 beta, which is plus 4 by 3. What is it going to be? It is going to be 3 minus 4. So 3 minus 4 is minus 1 by 3. And this is 3 plus 4, which is 7 by 3. So minus 1 by 3, 7 by 3, that 3 gets cancelled by this 3. So this is going to be the value of 10 alpha plus beta. But along with this, I need to put my comment on its quadrant as well. Okay, let's talk about this part here. Alpha is between pi to 3 pi by 2. Okay, so we know that alpha is between pi to 3 pi by 2. That's great. This is where alpha lies, pi to 3 pi by 2. And beta, we know lies between which values, students? Beta lies between pi by 2 to pi. So pi by 2 to pi. I hope there is no confusion on that. We know in inequalities we can add them. So if I'm adding them, I can conclude alpha plus beta will be greater than pi plus pi by 2. What is pi plus pi by 2? We know it is going to be 3 pi by 2. And it will be less than pi plus 3 pi by 2. So pi plus 3 pi by 2 is going to be 3 pi plus 2 pi, which is 5 pi by 2. I hope there is no confusion on that. Now, I hope you understand what is 3 pi by 2 and what is 5 pi by 2. If I were to simply tell you this here and this here, I hope you know that this is pi by 2, this is 2 pi. Then you have this as 3 pi by 2. Then of course this is pi, then this is 2 pi, then of course it is going to be 5 pi by 2. Do you remember that? So if this is 3 pi by 2, This is 5 pi by 2. So if I'm making any comment on alpha plus beta, it will be lying either in the fourth quadrant or first quadrant. Right. Now let's go back to the conclusion we have drawn. The value of 10 alpha plus beta we have received is minus 1 by 7. Now 10 of an angle is negative. 10 of an angle is negative. Do we have 10 ratio negative in the first quadrant? No, sir. In the first quadrant, all the ratios are positive. And in the fourth quadrant, cos and sec are positive, which means 10 should be negative. So in the fourth quadrant, 10 is negative, which means 10 alpha plus beta should be minus 1 by 7. And alpha plus beta, where we had this confusion that it will be either in the fourth quadrant or first quadrant, but since 10 alpha plus beta is negative, it cannot lie in the first quadrant. So it must lie in the fourth quadrant. So that will be my answer, that here alpha plus beta will lie in the fourth quadrant and its value will be minus 1 by 7. Did you understand the whole conclusion? Did you get the complete idea? How did we get it? Are you comfortable now? Are you understanding this whole concept? Are you learning the quadrant theory? Are you learning how are we using Pythagoras theorem? Are you understanding by quadrants? How am I using the sign scheme? And along with this, are you getting complete clarity on these identities which are going to be used? I hope no confusion on these identities, sin a plus b, cos a plus b, and tan a plus b. They are some really crucial identities, and trust me, they are used almost everywhere in your IIT JEE journey. Now, if I move towards the next set of rules, what are we going to discover now? Some very crucial formulae which are asked in your examination. Now, what are they? Let's have a look at them. Sin a plus b, sin a minus b. We have a detailed proof which I'll simply put here right there for you. I'll simply give you this idea. We know sin a plus b is this, sin a minus b is this. If I multiply them, a lot of terms will get cancelled. And after all those cancelification, you will get this sin square a minus sin square b. So this is a conclusion which I want emphasize you all to remember, that sin a plus b times sin a minus b. Please remember it. It is sin square a minus sin square b. I personally remember it like a plus b into a minus b, which is a square minus b square. In the same fashion here also, it is not true everywhere else. It is true for this sine formula only. So here, please remember, sin a plus b into sin a minus b can be written as sin square a minus sin square b. Additionally, what I can additionally do is sin square a I can write as 1 minus cos square a. Sin square b we can write as 1 minus cos square b. On the basis of this, after simplification, you can write it as cos square b minus cos square a as well. Please remember, sin a plus b into sin a minus b. Whenever you see something like this, you can unhesitatingly write this. And vice versa. If I happen to see something like this or this, I can replace it like this without any hesitation or confusion. Will you remember that? I hope there is no confusion on it. Now, moving ahead, what do we have next? Another very crucial identity, which is cos a plus b times cos a minus b. Of course, it has its own proof. Cos a plus b you can expand by using this formula. You can expand cos a minus b as well. You can multiply all the individual terms. Terms will get cancelled, and the final result will be this cos square a minus sin square b. I repeat, it will be cos square a minus sin square b. Of course, if you don't want to use this particular result, you can replace cos square a by what? 1 minus sin square a. So cos square a I can write as 1 minus sin square a. And sin square b I can write as 1 minus cos square b. So I hope that result is also there with you, that this one and this one are cancelled. And finally, you are left with another result, which is cos square b minus sin square a. Hope you will remember this also as a result here. But something very crucial, you have the proof. Even if you forget the proof, please do remember these identities. They are very crucial. They should be at your fingertips. Trust me, trigonometry is something which is a chapter solely, totally, and completely based on identities. So you need to learn a lot of identities, a lot of formulae we are going to discuss in this particular chapter. And you should be well versed with all those identities, all those formulae. So here, this identity which says cos a plus b into cos a minus b, I won't hesitate again in replacing it by cos square a minus sin square b, and vice versa. Whenever you see cos square a minus sin square b, don't hesitate in replacing it by cos a plus b or dot cos a minus b, as per the need of the question, of course. We won't do it always, but yes, if the need arises, we'll do it. Now, this is again a formula which you can get by simply expanding sin a plus b. Sin a plus b I can write as sin a cos b plus cos a sin b. This will be sin a cos b minus cos a sin b. So cos A sin B are cancelled. And what are we left with? Sin A cos B, but double of it. Because sin A cos B is found from here, sin A cos B found from here. So it will be 2 sin A cos B. So whenever I see 2 sin A cos B, I will, if I am asked or if need arises, let's say an integration, product is given. And if I wish to convert it into sum, because sum, then differentiation, integration will be simpler and possible. So if product is given, I can convert it into sum like this, that 2 sin A cos B, I can write as sin A plus B plus sin A minus B. I hope no confusion on that. Similarly, if I subtract sin A minus B from sin A plus B, what result do I get? In that case, I'll get the result as 2 cos A sin B, because sin A cos B, sin A cos B will get cancelled because there is a negative sign. But cos A sin B, cos A sin B will get added because minus of minus will be plus. So I'll get 2 times cos A sin B. Are you understanding their proofs? Along with their proofs, I hope you will remember these additional results as well, which I am very strongly asking you to remember. Please keep taking notes of these identities, although these short notes will be provided to you. You can keep this PDF, but in the short notes diary, where you're writing all the formulae, where you're keeping track of all the formulae of mathematics, in that diary, you should have these formulae with you. Now, moving ahead towards the next set of rules, what does it say? Let's say now if I not dual, if I deal with cos A plus B and cos A minus B, I'll add them, and the second time I'll simply subtract them. So if cos A minus B is added to cos A plus B, so cos A plus B is cos A cos B minus sin A sin B. It is cos A cos B plus sin A sin B. That sin A sin B is cancelled. What am I left with? 2 times cos A cos B. Did you get that part? Similarly, if I subtract cos A plus B from cos A minus B, why? The reason is simple. Cos A minus B is cos A cos B plus sin A sin B. And cos A plus B is cos A cos B minus sin A sin B. So I hope you're realizing cos A cos B are cancelled now. So what am I left with? I'm left with sin A sin B plus sin A sin B, which is 2 times sin A sin B. Did you get these two results as well? So again, I'll ask you to memorize these results, and the derivation of all these results lies to the same 3 simple identities of the formula which we discussed in the beginning: sin A plus B, cos A plus B, and tan A plus B. Through those identities only you can derive these results, but you should have these results at your fingertips. Similarly, now one more change I'm doing here. What is that change? Let's say here with this particular identity, let's say I replace A plus B by C and A minus B by D. I repeat, if I'm replacing, let's say, A plus B by C and A minus B by D, and if I add both of them, so B and B are cancelled, 2A is C plus D by 2. So C plus D by 2 is A, and of course, C minus D by 2 is B. Why am I saying so? Because now, if you replace A plus B by C, and if you replace A minus B by D, what do you get? You get sin C plus sin D. What is it? Sir, sin C plus sin D is going to be, I hope you can see, 2 sin. What is A? It is going to be 2 sin. What is A? A is C plus D by 2 cos B. What is B? B is C minus D by 2. So from this identity only, if I make some changes to it, I am now getting some more results. So let's say this was product to sum. Now I'm giving you a formula from sum to product. Did you get that? So in the same basis, and on the basis of same formula, we can draw these 4 more formulae. Which one? Here. I'll begin with the first one. So sin A plus sin B. I hope you remember sin A plus B plus sin A minus B. Through that only I'm doing this. So sin A plus sin B, we can on any day write as 2 sin A plus B by 2 cos A minus B by 2. Will you remember that result? Similarly, if I'm giving you sin A minus B, I hope now you remember it was cos A sin B. So this time it will be 2 times cos A plus B by 2 sin A minus B by 2. Similarly, 2 more results can be drawn. I hope you remember cos A plus cos B. I hope you remember cos A plus B plus cos A minus B was the formula. So instead of A plus B, if I C, instead of A minus B, if I put D, I'll get this result. So cos A plus cos B will be 2 cos A plus B by 2 into cos A minus B by 2. I hope there is no doubt or hesitation on that. Now, let's talk about this particular formula. This is a little tricky. Please remember this. Here, it is cos A minus cos B. It is cos A minus cos B. So this is written as 2 sine A plus B by 2 times sine B minus A by 2. I hope you remember. That's the tricky part. So if you don't remember it like this, I'll give you another variant of it. It is minus of 2 times the sine of A plus B by 2 times sine of A minus B by 2. And the proof remains the same, that you replace those A plus B and A minus B by C and D, and you will start getting all these four results where we have discussed sum or difference formula into product formula. Any confusions on that? I hope you are understanding this particular result. Why are we getting this result? Because the reason is this. It was cos A minus B minus cos A plus B. And that's why you should be more cautious or alert with this fourth formula of sum into product or difference into product. Did you get this result? Even if you forget this, you can draw it, derive it. But yes, rather than drawing it every time, do remember it. Now, this is also something very useful. How do we do it? The proof is pretty simple. You can write 10A as sin A upon cos A. We can write 10A as sin A upon cos A. And we can write 10B as sin B upon cos B. Now, I hope most of you must have started seeing that, sir, yes, the job is done. Why? Because now you would be seeing sin A cos B plus cos A sin B, which is sin A plus B in the numerator. And in the denominator, I'll have cos A cos B. So I hope the proof was pretty simple. The only thing you need to take care of is that A and B should not be any multiple of pi by 2. Why? Because at any multiple of pi by 2, 10 is not defined. Do you remember that? In the same fashion, if I give you 10A minus 10B, all you'll say is, sir, here put a minus sign. So sin A cos B minus cos A sin B, that is sin A minus B in the numerator. And the denominator will be again cos A cos B. Did you get that part? So proofs are simple, but you should have these results with you. I hope there is no doubt on that. In the same fashion, do you not think that these results can also be derived? Cot A plus cot B. Cot A I'll write as cos A upon sin A. Cot B I can write as cos B upon sin B. And then through LCM, I can have this result. Similarly, cot A minus cot B can also be written as sin B minus A upon sin A sin B. Again, this is a check here. It is not sin A minus B. It is sin B minus A. I hope you remember why. I hope there is no confusion on that. There is a complete clarity on this. Moving ahead, now let us discuss the multiple angles formula or ratio. Now, we have discussed sin A plus B. So instead of that B, if I replace that B by A, I'll have sin A plus A. So sin A plus A will be what? Sin A cos A plus sin A cos A. Sin A cos A, sin A cos A will be 2 sin A cos A. So first result will be that sin 2A will be 2 sin A cos A. Of course, here I could do one more thing. Here, if I am dividing or multiplying it by cos A in the numerator or denominator, the only change I'm doing is that it is 2 sin A, which is perfectly fine. But let's say I am dividing and multiplying it by cos A here. So if I'm multiplying it by cos A, it will become cos square A, and if I'm dividing it by cos A, it will be here sin A upon cos A. So sin A upon cos A can be written as 10A. So this is 2 10A. And cos square A in the denominator can be written as sec square A. And sec square A as an identity can be converted into 1 plus 10 square A. So did you understand this result? That sin 2A can also be treated as 2 10A upon 1 plus 10 square A. Usually what students do is they remember this one, but they forget this one. And I will ask you all to remember this one as well. 2 10A upon 1 plus 10 square A. Because in integration mostly, we deal with this particular formula. So please remember this as a result. Don't forget that. Now, if I move ahead with the next conclusion, cos 2A. What was cos A plus B? In that B, if I replace B by A, it will be cos A plus A. Cos A plus A will be cos 2A. It will be cos A minus sin A sin A, which means cos square A minus sin square A. So one of that identities is cos square A minus sin square A. If I replace sin square A by 1 minus cos square A, I'll get 2 cos square A minus 1. If I replace cos square A by 1 minus sin square A, I'll get 1 minus 2 sin square A. I hope these three formulae are very well understood by you all. In that same manner, there is one more version of it, which again students forget, which can be proved with the same way, the way we have proved this 2 10 upon 1 plus 10 square A, which is 1 minus 10 square A upon 1 plus 10 square A. What does it mean? It simply can be proven through this simple idea. What is 1 plus 10 square A? Sir, 1 plus 10 square is sec square A. So 1 upon sec square A will be cos square A. 10 square A upon sec square A will be sin square A. So cos square A minus sin square A can be written in this format only. Because sometimes we need to convert cos to a solely into cos formula, solely into sine formula, sometimes into cos and sine both, and sometimes cos to a is needed to be written in terms of tan a as well, only tan a. So that's where you need to have all these identities with you. Are you getting this result very clearly? Now, moving ahead towards the next data set, next formula, next set of identities, the conversion formula. Now look at this particular part. If I have this result, if I had this result, please understand this result that we had discussed that cos 2 theta was what? It was 2 cos square theta minus 1. So if I take this minus 1 to the other side, what will I have? I'll have 1 plus cos 2a as 2 cos square a. I am very strongly asking you to remember or urging you to remember this particular identity. JEE is madly in love with this particular identity. They keep on asking questions on it. A lot many times you would be seeing that I'll be either writing this as this, mostly in integration, or I'll be writing this as per the need of the question. So you should have these results with you that whenever you see 1 plus cos 2a, you can convert it into 2 cos square a. Not just that, remember this also as a result which you can draw from this identity only, which is basically 1 minus 2 sine square a, which is cos 2a. If I take cos 2a here and 2 sine square a there, you will see one more identity getting created, 1 minus cos 2a, which can be written as 2 sine square a. Please don't forget it. This is something again, a result which is very highly asked by IIT JEE. So these are the two identities which IIT JEE loves asking, and they are simply in love with these two identities. We will also keep using them as per the need of the question. That's exactly what we are given over here, that 1 plus cos 2a will be 2 cos square a. 1 minus cos 2a will be 2 sine square a. Similarly, if I divide this by this, what I'm trying to say is that, let's say if I divide here, let me write this particular identity here only, 1 minus cos 2a if I'm dividing by 1 plus cos 2a. So in the numerator, I'm having 1 minus cos 2a. In the denominator, I'm having 1 plus cos 2a. So are you not seeing what is 1 minus cos 2a? It is 2 sine square a. What is 1 plus cos 2a? It is 2 cos square a. So 2 sine square upon 2 cos square a, 2 is 2 cancelled. Sine square upon cos square is 10 square a. So don't forget this result as well, which is 1 minus cos 2a, which is 1 minus cos 2a upon 1 plus cos 2a can be written as 10 square a. Again, you will, once you start solving questions of ITG, once you start getting into the previous year's questions, you will see these identities being used. And that's where you'll strike that, yes, this is something which we were taught. So remember it. Not just that, if I take this 2 here, cos square a can be written as 1 plus cos 2a by 2. If I take this 2 here, 1 minus cos 2a by 2 can be written as sine square a. I hope you won't forget it. Similarly, this is again a formula. What we know is tan a plus b. In that formula, if I replace b by a, it will be tan a plus a, which is tan 2a, which is tan a plus tan a upon 1 minus tan a, which is tan a, which means tan a plus tan a will be what? 2 tan a upon 1 minus tan a will be 10 square a. So this is how you write tan 2a. That is again a very crucial formula. Do remember it. So I repeat, here also a should not be a multiple of pi by 4, odd multiple of pi by 4, because if a is an odd multiple of pi by 4, 2a will be an odd multiple of pi by 2, and again 2a will go not defined. So that is something which you should take care of. This is something which you must take care of. I hope you are understanding these nuances, because JEE loves playing with the nuances. They check your conceptual learning and your depth, that how clearly you know things, concepts. I hope you are understanding that part very clearly. I hope this part is very well understood by you all, and you must have understood its importance. Similarly, we had sine a plus b. In sine a plus b, if I replace b by 2a, then I'll have sine a plus 2a, which is sine 3a. So in sine 3a, I'll have this final conclusion as 3 sine a minus 4 sine cube a. This is the formula which you should have at your fingertips. And the other version of sine 3a is this, and I will show you previous year's questions asked on this formula directly. The question was something like this. I'll just create one here so that you understand it like this. The question, I'll just demonstrate it right there only. So the PYQ asked by JEE recently only, they even advanced has asked this particular PYQ a question based on this identity. What they did was they gave something like, let's say sine 60 minus a. Let's take A as 10 degrees. So they wrote sine 50 degree, then they gave sine 10 degree, and then they gave sine 60 plus 10, which is sine 70 degree. Now, most of you must be wondering, sir, we don't know the values of sine 10, sine 50, sine 70. How can we solve this question? But if you look at this pattern, this is nothing but what? Sine 60 minus A, sine A, sine 60 plus A into 4 is sine 3A. You can prove it through a very simple result. I am directly giving this result, that keep it with you. Why? Because see, this is sine A, this is sine A, this is sine 60 minus A, this is sine 60 plus A. What is it? Sir, it is sine 3A upon 4. It is sine 3A upon 4. So it should be sine 3A. What is A? A is 10 degree. So 3A will be sine 30 degree upon 4. Sine 30 is 1 by 2. So 1 by 2 by 4 is 1 by 8, and that would be the answer. Can you believe this? In 10 seconds or less than 10 seconds, you can simply look at this and do it. Only if you are able to crack the pattern, and you will be able to crack the pattern if you know that this identity is there. So remember that sine 3a is not just 3 sine a minus 4 sine cube a, which I'll keep using, which I'll keep drawing. But yes, along with this, sine 3a is 4 sine 60 minus a sine a 60 plus a. They keep on asking questions on this. So do remember that both of them are equally important. Not just that, this cube can also be written as something like that. What am I trying to say here is that let's say if I take 4 sine cube a on the other side, sine 3a I bring here on the other side. So can I not say that 4 sine cube a will be 3 sine a minus sine 3a. So do remember this also as a result. Whenever I deal with something like this, I will not hesitate in using this particular identity. Similarly here as well, that cos 3a can be written as 4 cos cube a minus 3 cos a, and the same 60 degree formula holds true here as well, that cos 3a can be written as 4 cos 60 minus a cos 60 plus a. Please remember that. Please remember that. Do you not think that a formula for tan 3a can also be derived from here as well by using these identities only? If I divide sine 3a by cos 3a, I'll have tan 3a. And here, this 4 and this 4 are cancelled. So, sin a upon cos a, sin 60 minus a upon cos 60 minus a, sin 60 plus a upon cos 60 plus a, which will give me tan 60 minus a into tan a into tan 60 plus a. Will you remember this identity as well? So, again, another identity can be formed based on this. Sir, are you trying to say that a lot of identities can be formed? Yes. You can create anything based on these identities. I am trying to give you as many as I can so that you remember them and use them in the questions and get the answers as soon as possible. Because at this stage, before going into the examination hall, you still have some time to learn these, to memorize these. So once you have mastered these by practicing questions like this, you have these at your fingertips. So in the real examination hall, you won't have to put efforts in deriving these results. So if you have these results, you can avail them as per the need of the question. Are you understanding the motive? Now, let's go ahead with the next set of formulae or identity or question. Tan 3a, of course. Tan a plus b, we know. If I replace b by 2a, I'll have tan a plus 2a, which is tan 3a, which is 3 tan a minus tan cube a upon 1 minus 3 tan square a. I hope you will remember this also is an identity. This is a very widely used identity. And we'll see these identities, implications, and applications in inverse trigonometric functions as well. In that chapter also, we'll keep using these identities. So remember them, that they are not just used here, they are used everywhere in your ITG mathematics. This is the importance of this particular chapter. This is a very easy chapter, does not look complicated or tough. The only challenge is that you should be able to memorize all the identities. Because if you are not, then again, you are making an error. Because if you're taking these identities lightly, which are used everywhere, then you won't be able to solve questions of other chapters as well. So I hope you're understanding the intent. Everything is equally important. And IIT JEE knows it. They know how to ask this with something else. So it is their responsibility that they'll ask you the entire chapter, entire syllabus through some different means. Directly, indirectly, subtly, through their own methods. But you should study everything. I hope you're getting the intent. Now, moving ahead with that, we have this thing with our mind that sine 2a was 2 sine a cos a. So if I replace a 2a by a, I have to replace a by 2. So here I can create some more formulae which can be written as which can be written as sine A is equals to 2 sine A by 2 cos A by 2. I hope you're understanding why, because 2A I have replaced by A, so A will get replaced by A by 2. Similarly, cos A can be written as cos square A by 2 minus sin square A by 2. Not just that, cos A can be written as 2 cos square A by 2 minus 1, or 1 minus 2 sin square A by 2, and something like that. So I hope you remember the formulae which we have already discussed so far. Same stays true with 10a as well. So 10 2a was 2 10a upon 1 minus 10 square a. So 10a will be 2 10a by 2 upon 1 minus 10 square a by 2. Depending on the need, we will use these identities or use this results. As we know that sine 2a was 2 10a upon 1 plus 10 square a, the 10 version. So of course, if the need arises, I can use sine a as 2 10a by 2 upon 1 plus 10 square a by 2. We use these. I'm not just writing these for the sake of writing them here. Trust me, these are some really important and crucial identities which are used mostly in integration, definite integration, and a lot of other places as well. But yes, mostly in integration. So remember these identities. Now, moving ahead, yes, cos 2a, as we have discussed, was 1 minus 10 square a upon 1 plus 10 square a. So cos a will be 1 minus 10 square a by 2 upon 1 plus 10 square a by 2. I hope there is no doubt or confusion on that. Yes, cot is also there, but let's remember sine, cos, and tan only. That will be suffice. That will be sufficient. Look at this category of question. For this category of question, there is a formula as well, which again make you get confused at this stage. So I'll rather tell you the approach, because now JEE has understood that students have learned a lot of identities and they apply the identities and get the answers. So now they have, giving some areas where you may get confused. So that's where let's try and solve this question through standard method. So this is the previous year question of JEE Mains 2022. It was the year when they have asked it. First of all, the product is given. And when they give you something like this, and when they give you options have numbers, then it should be solvable. It should be solved. Idea is, can I convert all of these ratios into cos? How can I do that? Please look at this part. Sine pi by 22. If I need this sine pi by 22, can I write, I hope first of all you must have understood this thing very clearly, that sine theta I can write as cos 90 minus theta. Why? Because 90 lies on the y-axis, which means cos will be becoming sine. When you talk about sine, 90 minus theta is first quadrant. So cos 90 minus theta will be sine theta, plus sine theta, positive sine theta. Are you getting it very clearly? Now, let me talk about this part. Sine pi by 22, 3 pi by 22. This looks like in a pattern, but I'll be able to solve this question more clearly if all of these angles are given in cos ratio. Why? You'll understand in the next step, but as of now, just look what I'm doing right now. So here, if I begin with this part, 2 sine pi by 22. 2, let's talk about later. Sine pi by 22. Sine pi by 22. Can I write this as cos pi by 2 minus pi by 22? I hope I can do that. By using the same logic, sine theta is cos 90 minus theta. I hope I can do that. No confusions on that. What is it going to be? If pi by 2, can I not write pi by 2 as 11 pi by 22? Because pi by 2 can be written as 11 pi by 2, so that LCM becomes simpler. So here LCM is going to be 22. So 11 pi minus pi will be 10 pi. So this I'm writing as cos. I hope there is no confusion on that. It was pi by 22. So 11 pi minus pi is 10 pi by 22. So I'm writing it as 10 pi by 22. So sine pi by 22, I'm writing as cos 10 pi by 22. You could write it as even 5 pi by 11 as well. That can also be done, but let's keep it like this only. Even 5 pi by 11 is also perfectly fine. Nothing wrong in that, right? So I'm taking it as cos 10 pi by 22. I am seeing a reason because I am seeing it getting doubled. So I'm keeping it 10 pi by 22 deliberately. So this sine pi by 22, I'm writing as 2 is there. Cos 10, what is wrong with this? Cos 10 pi by 22. I hope there is no confusion on that. Now, moving ahead. The next was sine 3 pi by 22. So here, if I am willing to find sine 3 pi by 22, this will be sine 3 pi by cos 11 pi by 22 minus 3 pi by 22. So 11 minus 3 we all know is how much? I hope you know that it is going to be 8 pi by 22 now. Did you get that part? I hope there is no confusion on that. 11 minus 3 we all know is 8 pi by 22. Did you get that? So this sine 3 pi by 2, I'll be writing as cos 8 pi by 22. Yes, it can be cancelled, but I'm deliberately keeping it like this. There is a reason. You'll understand why. So I hope you must have seen the pattern. Now, if I talk about sine 5 pi by 22, by pattern, I can write it as cos 11 minus 5, which is 6 pi by 22. So I hope there is no confusion on that. So 10, 8, 6. This will be 11 minus 7, 4. 11 minus 9, 2. So this will be cos 4 pi by 22, and the next will be cos 11 minus 9, 2 pi by 22. That's the result we have brought so far by using this particular calculation. I hope no confusion on that. You must be able to understand this very clearly. Now, what if I multiply and divide this expression by 2 sine 2 pi by 22? Sir, why are you doing this? Let me do it. Have faith in the process. Why am I doing it? You'll get to understand this in the very next step, and then you'll find a chain, and then that chain will break, and you'll get the answer in the next 10 seconds. If you are intelligent enough, which you all are, trust me. So now I am multiplying and dividing it by sine 2 pi by 22. So of course, I am multiplying and dividing it by sine 2 pi by 22. So I have sine 2 pi by 22 in the denominator. This 2 I'll write later. So here also I'm having sine. These options are there. Don't worry about them. Sine 2 pi by 22. And this 2 was also there. So I'm writing this 2 here. I hope you don't get confused with that. Now look at this part. I'm asking you to put your complete focus on 2 sine theta. Just give me a second. 2 sine theta cos theta. What is the identity we know about 2 sine theta cos theta? So that is sine 2 theta. So do you not think that 2 sine 2 pi by 22 cos 2 pi by 22 can be written as, or can be replaced by, sine 4 pi by 22? That was the reason I did it. It is sine 4 pi by 22. Along with this, we have this cos 4 pi by 22. Along with this, we have this cos 6 pi and 8 pi. So I'm writing those also, cos 6 pi by 22. And then cos 8 pi by 22. This is what I'll not be writing again, but to not make you get confused, that's why I'm doing it very clearly. And of course, the next term is cos 10 pi by 22. So it is going to be cos 10 pi by 22 whole divided by sine 2 pi by 22. So this is divided by sine 2 pi by 22. I hope you have understood that 2 sine 2 pi by 22 with cos 2 pi by 22 has been converted into sine 4 pi by 22. Any confusions on that? I hope you are comfortably getting it. Now, let me multiply and divide this expression, basically numerator and denominator, by 2. So I'm putting a 2 here, so I'm supposed to put a 2 here as well. Now, are you not seeing 2 sine theta cos theta? Is again what? It is again sine 2 theta. So can I again now not replace 2 sine 4 pi by 22 cos 4 pi by 22 by sine 8 pi by 22? Did you get that? I hope no confusion in that. Now, similarly, I'll again multiply and divide it by 2. When you do that, are you not seeing again a pattern getting created here? 2 sine theta cos theta, which is again sine 2 theta. So this expression over here, 2 sine 8 pi by 22 cos 8 pi by 22, can I not replace that by sine 16 pi by 22? I hope you are comfortably understanding what I'm doing right now. Any confusions on that so far? I hope you are having great clarity on that. Now, how do we solve this further? I hope there is no confusion on that part. So far, we are very much clear with whatever I've done so far. Now, I'll start simplifying this. I'll use that simplified result now. That cancellation part which we have been skipping, that 8 pi by 22, why did I not cancel that? Now let me do that. So first of all, let me see the pattern. Which one can be matched? So here, 16 pi by 22, right? So 22, if I write it as, if I write 22 minus 6, how much is it? Is it 16? Is it 16? So let me use that result. So we have a result. I'll use this particular result. Okay, I'll use another result. Let me use the next page. See, sine 16 pi by 22, right? Can I write it as sine 22 pi minus 6 pi, because 22 minus 6 is 16. Do you all get that? So 16 I'm writing as 22 minus 6. I hope I can do that. No problems in that, I believe. So 16 pi I have written as 22 minus 6, which makes it as sine 22 by 22 is pi minus 6 pi by 22. Did you get that? And we know where do we have this pi? This pi lies here on the negative x-axis. So pi minus anything will push me in the second quadrant. In the second quadrant, sine is positive. This pi is on the x-axis, which means ratio wouldn't change. So this sine pi minus theta should be sine theta, which is sine 6 pi by 22. So the sine 16 pi by 22 can be written or replaced by sine 6 pi by 22. I hope I can write it as sine 6 pi by 22. So sine 6 pi by 22, cos 6 pi by 22, which I can write as 2 here and another 2 here. So this should be 2 cube now, right? So again, can you not see? Can you not see? Here again, 2 sine theta cos theta, which is again sine 2 theta, which is sine 12 pi by 22. So this now can be written as sine 12 pi by 22. So this has now become sine 12 pi by 22. The job is almost done. It is almost over. Again, 22 minus 12 is how much? 10. So can I not write 12 pi as, I hope, 22 pi minus 10 pi, which will again give me the same result. In that same result, if I am willing to find, what am I trying to find? Sine 12 pi by 22. Although I could have written it as 6 pi by 5 as well, but let me do it with this method only. 12 pi by 22, the same logic. 12 pi by 22, 22 minus 10, so it is going to be sine 10 pi by 22. Do you all agree with this? So here, this sine 12 pi by 22, I hope without any hesitation, I can write as sine 10 pi by 22. Did you get that part? I hope there is no confusion on that. Now, let me get to the next part. I am again multiplying and dividing it by 2. So this 2 cube will become 2 to the power 4, which is 16. Any doubts on that? Now, 2 sine theta cos theta. Are you seeing that chain getting created? That's exactly what happens with this category of questions. But you need to look at it from the right perspective. So here, 2 sine theta cos theta will be sine 2 theta, which is 20 pi by 22. So the numerator will be sine 20 pi by 22. Again, by using the same logic which we have discussed here, sine 20 pi by 22, can I not write it as sine pi minus 2 pi by 22? Although it could have been written as 10 pi by 11, but let me keep it like this only. So pi minus 2 pi by 22, I hope you can see sine pi minus theta, that is again sine theta, which is sine 2 pi by 22. So the numerator is basically, the numerator is sine 2 pi by 22. Can you not see? Can you not see sine 2 pi by 22, sine 2 pi by 22 getting cancelled? And finally, what are we left with? 1 upon 16, which is given in option A. Did you understand this whole process? Are you able to make some sense out of it? Did you get it? Although there could be some other approaches, and I would love to hear from you. So if you have any other idea, of course, there can be multiple approaches. I could have simply, simplified it like this: sine pi by 11, 5 pi by 11, 4 pi by 11, 3 pi by 11. Through that method also, we could have gotten the answer. But I chose to pick this up. And that's when I kept on doubling it, and then I kept on seeing it, and then through conversion, I could get it. And since it is trigonometry, it is an identity, you could have gotten it through some other method as well. So there can be multiple methods. And if there is any method which you feel should be discussed or brought under the light, then do write it in the comment box. I really love to hear from you all, because we all can learn from each other. And that's where you can come up with more responses suggesting that this could also be done. And of course, there can be some other better methods. So do write your responses. We would love to hear from you. If this particular question is understood by you all, let us move ahead with the next set of identities, which are sine 3a, cos 3a, and tan 3a, where again, instead of 3a, if I replace them by a, sine a can be 3 sine a by 3 minus 4 sine cube a by 3. Cos 3a, when 3a is replaced by a, cos a will be 4 cos cube a by 3 minus 3 cos a by 3. These are some standard results. The same you could do with tan 3a as well. So in tan 3a, you replace 3a by a. In that case, you write tan a is 3 tan a by 3 minus 10 cube a by 3 upon 1 minus 3 tan square a by 3. So do remember these results. And through that only, now we'll come to the part from where again IIT JEE loves asking questions. They are very much into this now. These days or these years, in the recent years, they are asking questions based on cos 18 degree, 10 7.2 degree and something like that only. So in this part of the video, now we'll be discussing how can you deal with this category of angles. I'll demonstrate some examples and I'll give you the hint or the clue or the idea through which you can work upon any angle based on its properties. How? Let's try and find out the value of sine 18 degree. How do we do that? So let's say I am asked to figure out the value of sine 18 degree. So let's say theta is 18 degree. So I treat 18 degree as theta. So you need to make some arrangements. For example, 18, if I treat as theta, we know 5 times of 18 is 90. What do I mean by that? 5 theta will be 90. Can I write 5 theta as 2 theta plus 3 theta? Yes, I can. So if I take that 2 theta on the other side, it will be 2 theta is equals to 90 minus 3 theta, or vice versa if I take 3 theta on the other side. If I take sine ratio on both the sides, because both the angles are equal, their sine ratios will also be equal. So sine 2 theta will be equal to sine 90 minus 3 theta. What is sine 90 minus theta? It is cos theta. So it is going to be sine 2 theta is equals to cos 3 theta. Did you get this result? Now I'll do something interesting here. Sine 2 theta, we know, has an identity which is 2 sine theta cos theta. Do we know something for cos 3 theta? Cos 3 theta is 4 cos cube theta minus 3 cos theta. Do you remember that identity as well? Now what I do next is, if I simply take this cos theta, cos theta, cos theta common, because cos theta cannot be 0, cos 18 degree is not 0. So I can take that common and cancel it out. So 2 sine theta is equals to 4 cos square theta minus 3. And that now when I replace cos square theta by 1 minus sine square theta becomes a quadratic like this. 4 sine square theta plus 2 sine theta minus 1. I hope so far whatever I've done is very well understood by you all. Now the next step, the very interesting next step. In this 4 sine square theta plus 2 sine theta minus 1, I'll solve it with the quadratic formula Sridharacharya, which is minus b plus minus b square minus 4ac upon 2a. Here I'll get two values of sine theta, which is these. Now, minus 1 minus root 5 by 4. This is a negative value. Sine 18 degree is what we are trying to figure out. Sine 18 degree. 18 degree is between 0 to 90 degree, which is in the first quadrant. And in the first quadrant, sine is positive. So I'll simply be discarding this value. Did you get that part? This is 18 degree. There's a small correction here. This is not 180. This is 18 degree, right? So here, if I could simply try and tell you this thing very clearly, that what will be the value of sine 80 degree, that should be positive value. Positive part is root 5 minus 1 by 4. So remember, sine 18 degree is always root 5 minus 1 by 4. This is something which should be there at your fingertips. This will be using at a lot of other places as well. So remember, first, how did we find the sine 18 degree? And second, you should remember this result. Not just that, once if you have found sine 18 degree, you can find cos 18 degree as well. Why? Because if I have sine 18 degree, 1 minus sine square 18 degree will be cos square 18 degree. Cos square theta is 1 minus sine square theta, right? So that logic or that pattern can be used. By simplification, I can have the value of cos 18 degree as well. Do you get that? If you have sine 18 degree and cos 18 degree, can you not find tan 18 degree? Sine 18 degree upon cos 18 degree. Not just that, if you have 18 degree, what is 19 degree minus 18 degree? Can you help me with that? Can you help me with that? So 90 minus 18, I hope you know, is 72. So you can find 72 degree as well. So if you know this 18 degree, you can talk about sine 72, cos 72 and tan 72 degree as well. Are you understanding that? If you have 72 degree, can you not talk about 36 degree? If you have 18 degree, can you not talk about 36 degree? Because 2a formula can be used. 3a formula can also be used. If you know 18 degree, triple of 18 is 54. So you can put some comments on 54 degree as well. So these are some conclusions which can be drawn. If you have 18 degree, can you not make a comment on 9 degree? Because half of 18 is 9. So such conversions, sine 2a formula, cos 3a formula, sine 3a formula, these formulae can be used and you can conclude or talk about other angles as well. Did you get that part? Are you able to make a lot of sense out of it? Now, if you are able to digest what I'm trying to say here, let us try a question which JEE has asked in 2021. And they keep on asking such questions. They're asking you a question that which quadratic has its one of the roots as cosec 18 degree. What is cosec 18 degree? Do you not remember we just had a discussion on sine 18 degree? Now, if sine 18 degree was root 5 minus 1 by 4, can you not say something about cosec 18 degree? It will be 4 upon root 5 minus 1. It will be 4 upon root 5 minus 1. So, it will be 4 upon root 5 minus 1. What I am talking about? I am talking about cosec 18 degree. So, let's say this is the value of x. This is one of the values of x, alpha or beta, whichever root you wish to take. So, if this is x, what is x? 4 upon root 5 minus 1, which is x, because it is cosec 18 degree, because sine 18 degree is root 5 minus 1 upon 4. I'll take root 5 minus 1 here. So it is going to be 4 is equals to root 5x minus x. Let me bring this x here. So it is going to be 4x, 4 plus x is equals to root 5x. If I square both these sides, what do I get? I get 16 plus x square plus 8x. And on the right hand side, what do we get? We get 5x square. Any confusions on that? 16 plus x square plus 8x is equals to 5x square. Now, what I do next is, let me take this x square on the other side. So 5x square minus x square will be 4x square. Then 8x when brought here will become minus 8x, and 16 when brought here will become minus 16 is equal to 0. I hope we are going great. 4x square minus 8x minus 16. If I take 4 common, it will give me x square minus 2x minus 2x minus 4 is equal to 0. So x square minus 2x minus 4 is equals to 0 given in the option A. Are you understanding that remembering these values can help you in such complicated questions in 3 or 4 steps? But yes, you should learn these. Some standard values I'm asking you to remember. Which standard values? Let me just show you those values. I'll come back to this part, but let me discuss these values. See, you know 30 degree, you know 30 degree, you know 45 degree. So can you not work out 15 degree? Sir, how? 45 minus 30 degree. Please understand. If I ask you sine 15 degree, will you not say it will be sine 45 minus 30 degree? So sine A cos B minus cos A sine B. That identity can be used and you can find sine 15 degree. Sine 15, if it is found, you can find cos 15. You can find tan 15 as well, sine 15 upon cos 15. Are you understanding it? Half of 15 degree is 7.5 degree. So if you have sine 15 degree, you can find 7.5 degree. Although it is not very easy and the values will make you understand that this is very difficult, but some values I will ask you to remember, which I'm highlighting those values. You should have this value 18 degree at your fingertips. This 18 degree you should have at your fingertips. At least sine 18 degree you should remember. You can work out cos based on that, and once you have sine and cos, you can work out 10. And once you have 18, you can very easily talk about 72 as well, because we know they are complementary. Did you get that part? So at least 18 degree is what you should remember. 15 degree you can work out by yourself. Why? Because 45 degree minus 30 degree is 15 degree. So that is very easy and simple. So yes, that can be derived easily. But even if you remember it, it will be more helpful. Even if you forget, deriving it is easy. Sine 18 degree is a little tough, but for 15 degree is very simple. 45 minus 30, very easily in 2 steps you can get the answer. So if you know sine 15, you can know cos 15, you can work out tan 15 as well. Along with this, some more are there. Some more are there. Of course, 75 degrees is something doable. Why? Why 75 is easy? Sir, it is basically 45 plus 30. 45 minus 30 was 15. So 45 plus 30 will be 75 through that. Or if you already know 15, 90 minus 15 is 75. So through that also you can do it. Are you understanding these different approaches? Also, if you could remember other, that is fine. But some which are straightforward should be remembered by you, at least the logics. Will you remember them? Now, there are some more. The story doesn't end, and this chapter is all about remembering and learning these identities, which will keep on discussing. So let us talk about when these ratios and angles appear in arithmetic or geometric progression. Now look at this part. Angles are given in AP. I hope you can make some sense out of it. The angles, see alpha, then alpha plus beta, then alpha plus 2 beta, then alpha plus 3 beta, up till the last angle, which is alpha plus n minus 1 beta. So these are n terms in an AP. Of course, this is not an AP. Sine alpha plus beta, sine alpha plus 2 beta, that is not an AP. There will be some simple values. But when you look at the angles are in AP. Alpha plus beta, alpha plus 2 beta. So if angles are found in AP, where you remember, alpha is the first term, beta is the common difference, and the number of terms are n. In that case, you can directly write the final result as sine n beta by 2 dot times sine alpha plus n minus 1 beta by 2 whole divided by sine beta by 2. The only change happens is this, that when it is given in cos. So this is the formula if angles are in AP when sine ratio is taken. If the same formula needs to be applied when cos ratio is given with the same angles in being AP. In that case, the formula remains the same, sine n beta by 2 upon sine beta by 2 times whole of, previously we had sine, this time we'll have cos alpha plus n minus 1 beta by 2. Will you remember these two formulae? I hope there is no confusion on that. Now, if I were to simply take an example, for example, let's say someday you deal with a question which says sine, let's say a plus let's say sine 3a plus let's say sine 5a and so on. Let's say such 7 terms are given to you, right? Such 7 terms are given to you. But what pattern you must have recognized or seen here is that, sir, here that first value a is alpha, then a plus 2a. So 2a here is beta. So what is beta? Beta is 2a. And how many terms are there? 7. So the value of n will be 7. So once you crack such pattern, you need not apply the formula sin C plus sin D and then sin C plus C, sin C plus sin D time again. If you look at the pattern, if you recognize that the angles are in AP, then you can use this formula. I hope the formula is pretty simple. If you remember it, then you can crack such questions with a lot of ease. I totally get it that remembering this formula is tricky, but even if you look at the pattern, those two formulae can be summarized or clubbed into one formula, and that's where you can simply distinguish it with cos and sine. Whenever sine is there, you will see a sine here, but whenever cos is there, you will see a cos here. Otherwise, rest of the formula remains same. Did you get that part? Now, let me move to the next part of our video. I hope you are understanding what is the formula and in what cases should you be using this category of formulae, right? Moving ahead, the way we have learned sine A plus B, in the same fashion, you can have a formula for sine A plus B plus C. In the same fashion, you can have a formula for cos A plus B plus C. I'll give you the generalized version of it. Now, what do I mean by generalized version of it? This. Remember this formula. This will help you in getting the answer more quickly. Remember this. This will help you getting the answer more quickly. Although this is not very widely used or asked, but yes, sometimes they are used, and that's when you may require them. Now, how do you use them? Let me try and teach you that, and let's use it. Let's learn how to use it. For example, I'm given sine A plus B plus C plus D up till n angles are there. How do we do that? First of all, take cosine of all these ratios and take product of them. So cos A1, cos A2, cos A3 up till all the angles times. You write S1 minus S3 plus S5 minus S7. Now what is S1, S3, S5, S7? I'll talk about that later. Don't worry about it. Let us write it like this. This is it. This is the formula for this. What if the formula is cos of A plus B plus C plus D, something like that? Then you take again cos A1, cos A2, cos A3 up till cos AN, cos of angles of all those values which we are given over here, and take the product times whole of. Previously, I took S1, S3, S5, S7 alternatively plus minus sign. Even. This time odd. S0, S2, S4, S6. S0 is 1 basically. Again plus minus alternatively. But what is this S1, S2, S3? What is that? Let's talk about that. Before I talk about that, let me come to one more formula, then I'll talk about that. Here also there is a formula which is 10 A1 plus A2 plus A3 up till AN. Here also you write it by, in the numerator, you write all the odd ones. So S1, S3, S5, S7 alternatively plus minus. In the denominator, you write all the even ones. So S0, which is 1 minus S2 plus S4 minus S6 and so on. Now, sir, what is this S1, S2, S3? What is it? So trust me, S1 is sum of the 10 ratio of angle taken one at a time, which means 10A plus 10B plus 10C plus 10D. And what is S2? It is taken 2 at a time, 10A 10B plus 10A 10C plus 10A 10D, 2 at a time. What is S3? Taken 3 at a time, 10A 10B 10C, 10A 10B 10D, 10A 10B 10E, something like that, 3 at a time. So I hope you're understanding what is it. Now, if you have learnt this, I can help you in creating any formula, whatever you need to. For example, let's say we need to build a formula for, let's say, 10 A plus B plus C. Now, how do you create a formula for this? What does it say? So the numerator should have the odd one. So first of all, I'll write S1. Now, what is S1? Sir, S1 is 10A plus 10B plus 10C. Great, that's brilliant. Minus S3. What is S3? Taken 3 at a time. So 10A, 10B, 10C. So I hope I'll write S3. So I'll write 10a, 10b, and 10c divided by S naught, which is 1, minus S2. I hope I cannot write S5 further because there were no 5, 10a, 10b, 10c, 10d, 10e like that. There were 3 only. So I'll stop at S3. In the numerator, I'll begin with 1, which is S naught, then minus S2. What is S2? 10a, 10b, plus 10b, 10c, plus 10c, 10a. So 1 minus sum of 2 at a time. 10a, 10b, plus 10a, 10c, plus 10b, 10c. I hope you're writing that. You're understanding that. 10b, 10c. But of course, this negative will make all of them negative. So this is how you write the formula for any version. So the generalized form goes like this. You need to remember this, this, and this. And on the basis of this, you can create any of these. So you need not remember all of these versions. I'm asking you to remember only these ones, these 3 ones. Which 3 ones, students? 1, 2, and this third one, which is the most important. IIT JEE asks questions on this only. Even from this only, you can create the formula for 10 3a. How? Let me try and tell you that. Now, let's say if I'm interested in creating 10 3a. So what is 10 3a? It is 10a plus a plus a. So first of all, S1. S1 will be 10a plus 10a plus 10a, which is 3 10a. Did you get that? Minus S3. What is S3? 10a into 10a into 10a, which will be 10 cube a. Are you getting it? Upon S naught, which is 1, minus S2. What is S2? 10a 10a, minus 10a 10a, minus 10a 10a, which means 3 10 square a. So are you getting it? How are we creating it? With the help of this simple logic only. So remember this. And to remember this, I'll always suggest that you should remember this. If you remember this result, it will help you or assist you in remembering or learning all the other formulas as well based on it. So I hope you are understanding the importance of this formula. This is a very crucial, very important formula, which will help you in deriving a lot of other results. Did you get that part? I hope there is no confusion on that. Let us move ahead towards the next part. What does it mean? This means, I'll just give you a very simple example to make you understand this very clearly. Let's take an example only. This is a question right here. So I'm given an expression 3 sin x plus 4 cos x. The constraint here is that this angle should be same. This angle should be same. If this is the case, then what the concept says is that 3 sin x plus 4 cos x will always lie between, I'm telling the concept with this example only. 3 sin x plus 4 cos x will always lie between negative of under root over sum of the squares of 3 and 4, which is 3 square plus 4 square. And it will always be less than positive of under root over square of sum of square of 3 and 4. Did you get my point here? I'll get back to this conclusion here. What I'm trying to say is that a cos theta plus b sin theta is always greater than minus of under root a square plus b square, and it is always less than under root a square plus b square. That's exactly what I'm doing or saying here. Did you understand my part here? The part is very simple. 3 sin x plus 4 cos x. This x and this x should be same. If it is not same, this formula cannot be applied. This inequality cannot be applied. And what does it say? That 3 square plus 4 square. It is basically 9 plus 16, 25, which is under root 5. So that minus 5 to plus 5, it will lie between. Which expression? This expression. So a sin theta plus b cos theta always lies between negative of under root over a square plus b square to positive of under root over a square plus b square. Remember that. That is again a very crucial result, and I would ask you, very strongly urge you to remember this as a result. Again, they love it. They love asking it. Again, how? Look at this example only. How should we use this particular case in this question? Now, please understand this expression 3 sin x plus 4x, which is given as k plus 1, which is given as k plus 1. Now we know lies between minus 5, I hope you know, to plus 5. Can I subtract 1 from all the 3 sides of this inequality? We can. So minus 5 minus 1 is 6. This is going to be k, and 5 minus 1 is 4. So the k lies between minus 6 and 4. What was the question? The number of integral values of k for which this has a solution. K is a real number. So I hope if I were to calculate the number of integral values, so I hope I need not tell you now the answer, but if you want to know, the integral values of k will be minus 6, minus 5, minus 4 until 0. Then of course 1, 2, 3 until 4. So did you get this? and if I were to calculate or give you the number of integral values from here, would you not say, sir, from minus 6 to 0, these will be 7, because minus 6 to minus 1, 6 integer, 0 will be the 7th integer, and 7 plus these 4 integers will be total 11 integers. So my answer will be, there are 11 integral values of k for which this will have a solution. Why? Because 3 sin x plus 4 cos x is supposed to lie between minus 5 and 5. So this is given equal to k plus 1. So if this is equal to k plus 1, then we would know that this lies between minus 5 and 5. Then k plus 1 is also mandatorily supposed to lie between minus 5 and 5. And if we are told that k takes only integral values, I'll say k can take only minus 6, minus 5 up till 4 only. These are the only 11 integral values which k can take if this equation has a solution, if this equation needs to be solved, if this equation can be solved. So if this equation can be solved, that is possible only when k plus 1 falls under the range of it being solved. And this equation will be solved when this has an acceptable value. And we know that this lies between minus 5 and 5. This can never be less than 5. This can never be more than 5. This is the range of this expression. So in functions, when we were talking about range, which we'll keep discussing through different chapters, now whenever you see a question on a sin theta plus b cos theta, will you not be able to find the range of this question? Sometimes you use arithmetic mean greater than equal to geometric mean to find the range. Sometimes you use this particular kind of question. So in every single chapter, it will have its own method of solving or finding the range based on its type, and that's what we'll keep learning. So instead of telling you the method to find the range in the chapter function, we'll keep discussing these methods. For example, in application of derivatives, there will have different methods. The second derivative test, the first derivative test, monotonicity, and something like that. That is what we'll discuss in AOD. But at this stage, whenever you deal with questions like this, range-based questions, this is what you're supposed to do. Will you remember that? I hope there is no confusion on that. Can we move ahead? Can we move further? Now, this is the part from where we'll move or talk about the general results or general solutions or standard solutions or particular solutions or specific solutions of trigonometric equations. What does it mean? Let me try and make you understand this result. Let's say I tell you that sine theta is equal to 1 by 2. Now, what if I ask you to write its general solution? What will you say? Now, you will say, let's understand it from the perspective of the graph. So this is, let's say, the y-axis for a while. And here, let's say this is the x-axis. I hope you are able to understand this part here. Now, if I draw the graph of sine x, so this is how you draw the graph of sine x. Although I'm not drawing it very properly, but this is how it will probably look like. Now, we see 1 by 2 here. We know that this is 1. So 1 by 2 lies somewhere here. I hope you are getting it very clearly. So if I draw a line parallel to x-axis, which passes through 1 by 2, then of course it will be this only. That line will be this only. Did you get this part? Did you get this part? Now, this line which is passing through 1 by 2 parallel to the x-axis which I have drawn, at whichever points it is intersecting this curve sin x, at whichever points this is intersecting the curve sin x, will be the solutions of this particular equation, because at these points, this is a value of x, this is a value of x, this must be a value of x, this must also be a value of x. So these are different values. But how do I find all of these values? How do I generalize them? Because you know that sin x is a periodic function. So 1 by 2 does not happen at 30 degree only. 30 degree means what? You say pi by 6. I hope you are understanding it. So 30 degree, you want sine 30 degree or sine pi by 6 is not the only place where you'll find 1 by 2, because there are some more angles where you'll find that angle's sine ratio to be 1 by 2. But how do I find that general result? How do I give that generalization? There must be a formula for that. There must be a standardization for that, because not always you can just simply, you draw the graph and then you keep finding and keep looking like that. You cannot keep doing like this. So there should be a general result or formula for that. There are derivations for those general results in formulae, which we'll not be discussing. I'll directly be giving you those general results, which we'll be using in these questions. How? Let's look at this part. For example, this generalizations, I hope I need not tell you, as we have already discussed while discussing the graph of sine theta, that whenever somebody says that sine theta is 0, what do we say? The sine theta becomes 0 whenever theta is a multiple of pi. Because at pi, 2 pi, 3 pi, 4 pi, minus pi, sine theta becomes 0. Do you remember that? If I ask you sine theta is 1, what will be your generalization? If I ask you that sine theta is 1, you would say, okay, let's talk about cos theta being 0, then I'll come back to sine theta being 1. So if I talk about cos theta being 0, what will you say? Sir, cos theta is 0 whenever the angle is an odd multiple of pi by 2. Do you remember that? So 2n plus 1 times pi by 2 will be my solution. Are you understanding? This is how we are giving the general solutions. So 2n plus 1 for any integral value of n will be an odd number. And that odd number into pi by 2 will be an odd multiple of pi by 2, minus 3 pi by 2, minus 7 pi by 2, 3 pi by 2, 11 pi by 2, something like that. And these numbers are odd multiples of pi by 2, which means at these points, cos theta will be 0. For these values of theta, cos theta will be 0. Are you understanding this result very clearly? Similarly, let me give you more results. For example, if I talk about tan theta, we had a discussion on this. Whenever sine theta becomes 0, tan theta also becomes 0 because tan theta is sine theta upon cos theta. So sine theta was becoming 0 at all the odd multiples of pi. So tan theta will also become 0 at the odd sorry. Let me take my words back. Sine theta was becoming 0. Sine theta was becoming 0 at all the multiples of pi. So tan theta will also become 0 at all the multiples of pi. Pi, 2 pi, 3 pi, 4 pi, 7 pi. Anywhere you see a multiple of pi, at that angle, tan will be 0. I hope you are getting it. So that is the general solution. So are you understanding that generalization that tan theta is 0 only when theta is of n pi category, where n is any integer, minus 3 pi, minus 7 pi, something like that. So are you understanding these general results? I hope the way we are understanding or moving ahead in the same fashion. Now we'll talk about more general results. Look at this part. Let's say sine theta is equals to sine alpha. So the general solution is given by theta is equals to n pi plus minus 1 to the power n whole times alpha. Now you need to have it at your fingertips. You will have to memorize this. You will have to learn this formula. There is no other method. Of course, you can derive it. I'll share this derivation as well. But in the examination hall, you won't have the time to derive it time and again. What is the derivation? See, if sine theta is equals to sine alpha, I can write it as sine theta minus sine alpha. There is no problem in that. Now, once you have written it as sine theta minus sine alpha, you can use the identity sine c minus sine d, which is 2 cos c plus d by 2 sine c minus d by 2, where this product is 0. This product will be 0 when either this is 0 or this is 0. So I'll say cos theta plus alpha by 2 is 0 or sine theta minus alpha by 2 is 0. We know cos of an angle is 0 at all the odd multiples of pi by 2. We know sine of an angle is 0 at all the multiples of pi. So by having that generalization, I'll say theta plus alpha by 2 should be of the category 2m plus 1 times pi by 2 because cos of this was 0. Similarly, theta minus alpha by 2 should be of m pi category because sine of this was 0. And by having this, I can keep drawing some conclusions and ultimately I will reach to a conclusion that theta will be of the category n pi plus minus 1 to the power n alpha. I repeat, whenever you're given sine theta is equals to sine alpha, you can directly write this answer. What do I mean by that? What I'm trying to make you understand is I can use this in the question which I was trying to solve. Previously, we were solving sine theta is equals to 1 by 2. Now, can you help me with its general solution? How? See, 1 by 2 is 30 degree. Can I write it as sine theta is equals to sine 30 degree, or 30 in radians can be written as pi by 6. I hope there is no confusion on that. Now, compare it with this formula. Which formula? Sir, if sine theta is equals to sine alpha, theta is given by n pi plus minus 1 to the power n alpha, which means theta here will be given by n pi plus minus 1 to the power n alpha. What is alpha? Alpha is pi by 6. And that's how you can write the general solution. What is n here? N is basically an integer here. So you keep trying different values of n, you will keep getting different values of theta. So all those other values of theta for which you will get sine theta as 1 by 2 will be these only. You just keep putting other values of n, you'll keep getting these values. Are you getting it? So this is the general solution. If somebody asks me particular solution, a specific solution in a particular domain, I'll say try try different values of n, and then you'll get those different particular solutions as well. So that's how you find the general and particular solutions. In a domain, particular solution. General will be general, a simple, a regular one, a standardized one. Are you able to learn the difference here? Now, if I move ahead from here, I'll talk about the other result, which is cos theta is equals to cos alpha. This is again a general result, which again I'll ask you to remember. There is no substitute of it. You will have to remember or learn it. Now, what is that general result? If cos theta is equals to cos alpha, we say that theta is 2n pi plus minus alpha. The derivation is same. Cos theta is equals to cos alpha. You take cos alpha on the other side. So cos c minus cos d, it is minus 2 sin c plus d by 2, sin c minus d by 2. And then again, either this is 0 or this is 0. And through that, you can come to the conclusion, which is this only. What do I mean by that? Let's say, if there is a question given to me, I'll take an example. Let's say I'm given that cos theta is equal to, let's say, root 3 by 2. And you are asked to write the general solution. Now, if cos theta is root 3 by 2, we know cos theta, root 3 by 2. Can you give me an angle between 0 and pi where cos is root 3 by 2? I hope you understand that at 30 degree, we see it as root 3 by 2. 30 degree means what? Pi by 6. It should be cos pi by 6. So whenever cos theta is equals to cos alpha, theta is 2n pi plus minus alpha. So what is theta? Theta. 2n pi will remain as it is, plus minus alpha. What is alpha? Pi by 6, where this n is any integer number. Are you understanding it? Are you able to make some sense out of it? Did you get this particular part? I hope there is no confusion on this front. Now, if I move ahead towards the next conclusion, next property or next generalization, it will be this, that whenever somebody says that tan theta is equals to tan alpha, you say theta is equal to n pi plus alpha. You say that theta is equals to n pi plus alpha. Again, same conclusion can be drawn here. Tan theta, tan alpha, tan theta is sin theta upon cos theta, tan alpha is sin alpha upon cos alpha. Through cross multiplication, I'll have sin theta minus alpha is equals to 0, and sin theta minus alpha will be 0 when theta minus alpha is of n pi category, which means theta will be n pi plus alpha. Which means, again, if I could try and make you understand with an example, let's take an example. Let's say I'm told that tan theta is equals to 1. And I need to write the general solution. What will I say? I'll say, sir, 1 happens at pi by 4. Between minus pi by 2 and pi by 2, 1 happens at pi by 4 in 10 ratio. So tan theta is equals to tan alpha. What is alpha? Pi by 4. So theta will be given by n pi. Theta will be given by n pi plus alpha. Can you see that? And alpha is pi by 4. Now, let's say if I'm asked a general value, let's say I'm asked a specific value. I'm not asked this general solution. I'm asked the value of theta between 3 pi and 4 pi. So I'm looking for a solution between 3 pi and 4 pi. So I'm looking for a solution between 3 pi and 4 pi. Let's say that is also what I'm given in the question, that find a solution between 3 pi and 4 pi. So what will I do? I'll replace n by 3. So when you replace n by 3, what you get is 3 pi plus pi by 4. Can I replace n by 4? If I replace n by 4, it will be 4 pi plus pi by 4. That will be greater than 4 pi. I need a value which is less than 4 pi and greater than 3 pi, which is this only. So 3 pi plus pi by 4. If I simplify this, it will be 12 plus 1, which is 13 pi by 4. So this is what I meant by specific solution. So let's say our question says, find the solution between 3 pi and 4 pi. That will be 13 pi by 4 to this question. Are you able to differentiate the general solution and the specific solution? Any confusions on that? Are you able to make or get some sense out of it? Now, let us move ahead towards the next part. What do we have here? If this part is understood by you all, there are some more conclusions. 3 conclusions through one formula, one generalized formula only. Sin square theta is equals to sin square alpha, cos square theta is equals to cos square alpha, or tan square theta is equals to tan square alpha is always given by this standard theta is equal to n pi plus minus alpha. For these 3 formulae, there is this one single generalization only. What is the proof? Sin square theta is equals to sin square alpha. Can I write it as 1 minus cos 2 theta, 1 minus cos 2 alpha by 2? I hope you remember this formula. Do you remember that? This is the identity. Now, I hope you can see it very clearly from here only. I can write it as cos 2 theta is equals to cos alpha, which means 2 theta is equals to 2n plus minus 2n pi plus minus 2 alpha. 2 to 2 are cancelled. Theta is going to be n pi plus minus alpha. That's exactly what I'm giving. Same you could do with this. The same you could do with this. I hope you're understanding. More important for us is to remember this result. What do I mean by this part here? Let's say in a question, I finally reach to a conclusion where I say that sin square theta is equal to, let's say 3 by 4. Sin square theta is 3 by 4. Now, can I write it as sin square theta is equals to root 3 by 2 whole square? I hope you're getting it. Now, instead of treating it like this, can I solve this question in a manner that where I say sine square theta is equal to what is root 3 by 2 in sine theta? In sine, root 3 by 2 is 60 degree. I hope you remember that is pi by 3. I hope there is no confusion on it. So it is going to be sine pi by 3, but its square is needed to be done. Now you must see a pattern here. Sine square theta is equals to sine square alpha. What does it mean? It means theta should be n pi plus minus alpha. So theta will be n pi plus minus alpha, which is pi by 3. Did you understand how did we find a solution? Let's say it is asking you to write a solution between 2 pi and 3 pi. Let's say they are asking a solution. Let's say the question said that theta should lie between 2 pi and 3 pi. You need to find a specific solution between 2 pi and 3 pi. What will I say? I'll replace n by 2. But when you replace n by 2, 2 minus pi by 3 will be discarded because I need greater than 2 pi. But 2 pi plus pi by 3 will be an acceptable solution. So my first solution will be 2 pi plus pi by 3. Can I have some other solution? Let's try that. If I replace n by 3, I'll have 3 pi plus pi by 3. That will be discarded because it will be greater than 3 pi. But I have one more choice, 3 pi minus pi by 3. That is an acceptable solution because it is less than 3 pi. So these are the two specific solutions, particular solutions I'm getting. Are you able to learn the difference between general solution and specific or a particular solution through this particular formula or approach or solution? Now, let us move ahead towards the next part here. What do we have? This is already we have proved cos square theta, tan square theta. We have already gotten this result. These are some common conclusions we have already brought. This is the summary I'm trying to give you. So take a screenshot of this page and I'll show you the next page also. Take a screenshot of that page as well. This is the generalization of trigonometric equations. So take a screenshot of this page as well. This page as well. I hope you have taken the screenshot. Now, this page as well. So these are the 11 formulae which I'm insisting you all to remember. Why? They say that trigonometric equation is removed from the syllabus. Now look at this scenario. 2025, they had asked a question on trigonometric equations where we'll be using this summary which I have asked you to take screenshots of. So remember, they tell you a lot of things. Don't blindly follow them because they have this habit of playing with your emotions. The JEE and TA. I hope you must have faced it previously as well. The same we are doing or facing here. So as per the syllabus, it is not included, but it is there in their questions. So again, we'll learn it and we'll learn how to apply it. So let's apply it in this particular question. The number of solutions of this particular equation in minus pi by 2 to pi by 2. So the problem is they're not asking for general solution. They're asking for specific solution. But a specific solution can be attained only once you have generalized the result. So I think I need to reach to the general solutions conclusion. I hope there is no confusion on that part. Now, let me try and solve this particular question. How do I do it? Now let's have a look at that. So what are we given? We are given cos 2 theta times cos theta by 2. That's fine. This cos 5 theta by 2 I'm taking to the other side. So this becomes 2 cos cube 5 theta by 2 minus cos 5 theta by 2. I hope there is no confusion on that. I hope there is a great clarity on that. So we have cos 2 theta, cos theta by 2, 2 cos cube 5 theta by 2 minus cos 5 theta by 2. I hope everybody is comfortably understanding this. What if I take this cos 5 theta by 2 common from here? What happens then? So the LHS I'm keeping intact. I'm not doing much with the LHS. I'm keeping it like this only. So we have cos 2 theta. Then we have cos theta by 2. I'm not doing much with this, but let's talk about this RHS. If I take cos 5 theta by 2 common, what am I left with? I'll be left with 2. What's wrong with this system? 2 cos square 5 theta by 2 minus 1. Do you all agree with this? Now, let me take you to a formula which we have learned, that what is the identity 2 cos square theta minus 1. Do you remember? This is the identity for cos 2 theta. I hope you haven't forgotten that. So if I talk about this, here we have this LHS which I will still keep intact, cos 2 theta into cos theta by 2. But here it is cos 5 theta. It is cos 5 theta by 2 times what? Times 2 cos square theta minus 1 is cos 2 theta. So cos 2 theta will be cos 5 theta by 2 double, which is going to be cos 5 theta. Did you get that part? I hope there is no confusion on that. Now, what if I multiply both the sides by 2? Why are you doing this, sir? Let me do it first. Now, why did I do this? Can you help me with 2 cos C cos D? Do you remember a formula for this? Have you? I hope you must have remembered it. There was an identity which said cos C plus D. There was an identity which said cos C minus D. Now, even if you forget, you can create it by doing this. Cos C plus D will be cos C cos D minus sin C sin D. This will be cos C cos D plus sin C sin D. So plus sin C sin D will get cancelled by minus sin C sin D. So we'll be left with 2 cos C cos D. So I hope you're realizing 2 cos C cos D can be replaced by cos C plus D plus cos C minus D. That's exactly what I'll do on both these sides. I hope you're imagining this question, that it is using all what you are being taught so far. So here 2 cos C cos D can be written as cos C plus D. So 2 theta plus theta by 2 is basically 2.5, which is 5 by 2. So it is 5 theta by 2 plus cos C minus D. So 2 minus half is basically 1.5, which is 3 by 2, I think, right? So 4 minus 1, this is 3. So it is going to be cos 3 theta by 2. Correct me if I'm wrong. I hope we are going great. So 2 plus half is 5 by 2 and 2 minus half is 3 by 2. Great, great, great. Now, this is going to be cos again C plus D. 5 theta by 2 plus 5 theta. So it's like 1 plus half, which is basically 3 by 2. So 3 into 5, 15 by 2. If you don't get it, 2 into 5, 10. 10 plus 5 is 15. So it is going to be cos 15 theta by 2 plus cos C minus D. Again, cos is an even function. So even if you do this minus this or this minus this, it will be fine. Why? Because cos is an even function. What do I mean by cos even function? That cos minus theta is cos theta. Why? Because this is 0. So 0 minus will push you in the fourth quadrant. In the fourth quadrant, cos is positive. And 0 minus, which means x-axis, which means cos ratio won't change. So cos minus theta is cos theta. Remember it, this is an even function. So here as well, if I subtract this from this or this from this, that negative value can be absorbed by cos because it is an even function. So I'll do this, 5 theta minus 5 theta by 2. So this is, let's say, a minus a by 2 will be a by 2. Even if you don't understand this, it will be 5 theta minus 10 theta, which is minus 5 theta by 2, which is 5 theta by 2 because cos is an even function. So did you understand this particular result? Now, from here, I can do this cancelification. 5 theta by 2, 5 theta by 2 is cancelled, subtracted basically. I haven't cancelled or divided it here. No, I've subtracted and no root loss is happening. Root loss doesn't happen when you add or subtract. When you divide a variable, that's when root loss happens. I hope you understand what is the root loss. When you talk about root loss, let's say x cube is given as x square and you're solving it. So some of you might say, sir, x square is cancelled and x is equal to 1. That's wrong. That is one of the options, but that is not the correct answer because it should have been solved like this. X cube minus x square is equals to 0. When you take x square common, x minus 1 is equals to 0 and the solutions will be x is equals to 0 and x is equals to 1. So that's the problem, students. Do or commit here. I hope you don't divide a variable in an equation just like that. No, you don't do that. Even if you're willing to do that, take that variable's value 0. For example, even if I'm dividing x square by x, then I should consider the value of x as 0, then it will become correct. That's the phenomena of root loss. Let me get back to the discussion we were having here. So I can cancel cos 5 theta by 2, cos 5 theta by 2 on the LHS and right hand side because it is subtraction, it is not division. So here no root loss is happening, mind you. So cos 3 theta by 2 is equals to cos 15 theta by 2. That's what I have received finally. Cos 3 theta by 2 is equals to cos 15 theta by 2. Let me recheck this part. Cos 3 theta by 2 is equals to cos 15 theta by 2. Yes, that's great. Now, can I ask you the general solution? What do I mean by general solution? If I am given cos theta is equals to cos alpha, we know theta is 2 in pi plus minus alpha. I hope you haven't forgotten this result, the general solution. This is theta, this is alpha. Can I say that theta, which is 3 theta by 2, should be equal to 2 n pi plus minus alpha? What is alpha? Alpha is 15 theta by 2. From here, two branches are getting opened when I take plus sign and when I take minus sign. So let me take the plus sign first. So when I take plus sign, it will be 3 theta by 2 minus 15 theta by 2 is equals to 2 n pi. When I take the minus sign, it will be 3 theta by 2. What is wrong with this? 3 theta by 2 plus 15 theta by 2 is equals to 2 n pi. Are you understanding it? When I take plus sign, it goes to the left hand side, it becomes negative. When I take the negative sign, it goes to the left hand side, it becomes positive. Did you get that part? Now, moving ahead and solving it further, what do I get next? 3 minus 15, it I think is how much? Tell me quickly. This is 12, I believe. 15 minus 3, 12. And 12, half of 12 is 6. So this is minus 6 theta. So minus 6 theta is equals to 2 n pi, right? I hope we are going great. 3 minus 15, 12. 12 by 2 is 6, minus 6 basically. So minus 6 theta is 2 n pi. So theta should be 2 n pi by 6 minus basically, so negative 2 by 3, 2 by 6 is 1 by 3. So it should be n pi by 3. That is the value of theta, a general solution of theta. Did you get that part? Now, moving ahead towards this part, 3 plus 15 is basically 18. 18 by 2 is 18 by 2 is 18 by 2 is 9. So this is 9 theta. This is 9 theta. So 9 theta is equals to 2 n pi. From here, theta will be 2n will be there. You cannot get rid of it. I hope I cannot get rid of 2. Yes, 2 is going to be there. So 2n pi by 9. Or you can say n times 2 pi by 9. Let me do that. N times 2 pi by 9. Right? I'm deliberately doing it. I hope we are going great. 15, 3, 18, 18 by 2, 9, 2n pi. So theta is 2n pi by 9, which I'm writing as n times 2 pi by 9. Now, let me get back to the question. Why? Because we were told that theta is not just anything. Theta must lie between minus pi by 2 to pi by 2. So I'll start trying some values. And for those values, I will ensure that my theta lies between minus pi by 2 to pi by 2. I hope you remember minus pi by 2 to pi by 2. If in a very simple language, I will try to understand this, that I need my answer to be lying between minus 90 degree to 90 degree. If you don't understand radians, that's why I'm writing like this. What is pi by 3? We know pi by 3 is 60 degree. I hope you understand this. Pi by 3 is 60 degree. Pi by 3 is 60 degree. I'm just trying to think that what values of n will help me getting that. Please understand, if I take the value of n as 2, so this will be minus 2. So minus 2 into 60 degree will be minus 120 degree. So I cannot take n as 2. So I'm restricting it to 1. If I take n as 1, it will be minus pi by 3, which means minus 60 degree. That is an acceptable value. So first value of theta from here will be minus pi by 3. If I take n as 0, it will be 0. That is an acceptable value. If I take n as minus 1, it will be minus of minus pi by 3, which is pi by 3. But I hope you're realizing I cannot take n as 2 or minus 2, because in that case, I'll reach to 120 degree and minus 120 degree, which is beyond my scope, minus 90 to 90 degree. I hope you remember that. Now, let me talk about this particular result. I hope we are going great now. So theta from here will be what? Theta from here will be 2 pi by 9. What is pi by 9? Pi is 180 degree. 180 upon 9 is how much? 20 degree. 20 into 2 is 40 degree. So this is 40 degree in my sense. So 40 degree. 40 doubled when gives you 80 degree. So I think double is what I'll take so far. So what I'll do is I can take, first of all, when I put n as 0, I'll get 0. When I take n as 1, I'll get 2 pi by 9. When I take n as minus 1, I'll get minus 2 pi by 9. Now, when I take n as 2, that is also fine, because 2 into 2 pi by 9, which will be 4 pi by 9, that is still less than pi by 2. Are you getting this part? Because that will be 80 degree. 4 pi by 9. I hope you're understanding. 4 pi by 9. Pi by 9 is 20. 20 into 4. Let me just do it again. Pi by 9. Sorry. What have we done is, let me just do it once again, because I'm getting confused now. 2 pi by 9. What is it? It is how much? 20 into 2, 40 degree. So this is 40. This is minus 40. Double also I can take, which is 4 pi by 9. So 4 pi by 9 is also what I can take. So along with that, minus 4 pi by 9 can also be taken, because if it is 80 degree, it will be minus 80 degree. Did you get that? Did you understand this part? But further I cannot take, because if I take 3 here, 3 into 2 will be 6, or 3 by 9 is basically 1 by 3. This is 2 pi by 3, which is crossing a 90 degree limit. So I cannot have more than that. But here, if you club these answers, you might say 5 plus 3, 8 answers. No, that's wrong, because 0 is common in both these solutions. So 0 should be counted only once, either from here or here. So let's say this is giving me 3 solutions. This is giving me 4 solutions, because this 0 I have already counted. So 4 from here, 3 from here, I am getting 7 solutions, which is given in option A. Are you understanding that without having the knowledge of trigonometric equations, you could not solve it? That's the point I'm trying to make you understand here. Now, let us move ahead towards the next concept. Next concept, what are we given? Yes, this is what we have already discussed. We have already learned that A cos theta plus B sin theta should always lies between mod minus C2 plus C. What is minus C? Under root A square plus B square. We have learnt this concept. So whenever needed, we can use this particular result as per the requirement. Now, inequalities I'll teach you through this particular question. So through graphs, you can solve questions based on inequalities and equalities. Inequality and equality. How? Let me try and give you an example here. What does it say? Sometimes trigonometric equations are not sufficient to help you in question. Rather, you draw the graph and then you solve it. Mostly in those cases when you are asked the number of solutions. You are not asked the exact solutions, rather you are asked the number of solutions. So in that case, you seek help from the graphs. How? Let me try and help you that. Here. The number of solutions of this equation. What is the equation, sir? The equation says 2x plus 3 10x is equal to pi. All right, that's great. I know how to draw the graph of 10x. So can I not say that here 10x will be pi minus 2x whole divided by 3? Did you get this part? So let me treat it as two functions. Let's say the first function is 10x. First function is 10x. And the second, what is wrong with this system? And the second function is pi minus 2x by 3. These are the two functions, right? Now, can I draw the graphs of two functions? Because 10x is what we have already learned. And if you look at this, this is a linear equation in one variable. Basically, y should be the second variable. So if you are dealing with a linear equation in two variables, that will be a straight line. So I think I have 10x and I have straight line. If I draw the graphs of these two curves, I will see the points of intersection of these two curves. Those will be the number of solutions. Did you understand the approach? So through graphs also, you can solve the questions. How? Let's look at this particular example. Here. Please pay attention. Let's say I am given two curves. So let me draw the graph of 10x here first. So here I am going to draw the perfect. Look at this. In the first attempt only, I could draw a straight line. Here I didn't get the desired result, but let me fetch it downward a little here. What is happening here? So I'm taking it a little bit here. I hope that is perfect. Now, here, let me divide into certain segments. I am trying to draw it as accurate as possible. Sir, why are you putting so much efforts? Because the better graph you draw, the chances of you being accurate are higher. So whenever you are solving a question of an equation where you are trying to find the solution through graphs, so try to draw the graph as accurate as possible. In a rush, you may draw something wrong and then you may end up committing some mistakes. So I'm trying to bring it a little more closer so that I can reach up till the range which they are giving us in the question. I'll help you with this, but let me just complete this part first, then I'll come to the conclusion. So I'm taking a copy of it one more time. So let me take, what's wrong with this? Let me take a copy of this here. I think this is fine. Let me take a copy of this from here, and that I think is fine. Now, why did I do all this? Why am I doing all this? I may have to do or draw some more, but let's try to figure it out. X is between minus 2 pi and pi. X is between minus 2 pi and pi. Okay. So I hope you know that if I am taking this as 0, we know this is pi by 2, this is pi, this is 3 pi by 2. So I'll need to draw one more line. Let me draw one more line because there I'll have 2 pi, right? So I'll draw one more line there. This is going to be 2 pi. And here, if I take a copy of it, it possibly is going to be minus 2 pi. Let me check it. So 2 pi, 3 pi by 2, and this should be 2 pi. Same here. It should be minus pi by 2. This should be minus pi. This should be minus 3 pi by 2. And this should be minus 2 pi. I hope there is no confusion on that. Now, let us draw the graph of tan theta. So how do you draw the graph of 10x? So 10x, I hope you remember, goes like this and then this. And here also from pi to 3 pi by 2, it goes like this and then this. From 2 pi, 3 pi by 2 to 2 pi, it stays like this. And then 2 pi to forward, it goes like this. But that I need not draw because that is not in my domain. That is not what we are asked to figure out. So this is going to be the graph. A very rough sketch I have drawn, but still it is a good one to solve the question. This I hope you can see very clearly is the y-axis and this here is the x-axis. I hope there is no confusion on that data. You are comfortably understanding it very clearly. Now, This is our function fx, which is the graph of 10x. I hope there is no confusion on it. Now I'll be drawing the graph of pi minus 2x by 3. So there is a straight line we are dealing with. Pi minus 2x by 3. Let me just check it. Pi minus 2x by 3. Yes, that's the straight line we are dealing with. Now, how do we draw a straight line? Find its intercept. That's the best form. So I'm putting x as 0. So when you replace x by 0, you get y is equals to pi by 3. So 0 comma pi by 3. Where do you find 0 comma pi by 3? This is 0. Pi by 3 will be somewhere here. Let's say this is somewhere here. So this is point 0 comma pi by 3. This is a point 0 comma pi by 3. So the line must be passing through this point. I hope you're getting it very clearly. Then what do I have next? The next point will be, let's replace y by 0. There are other methods as well, but this is the easiest, I believe. If I replace y by 0, 0 into 3 will be 0. So pi is equals to 2x. So x should be pi by 2. Yes, x should be pi by 2. So the other point will be pi by 2 comma 0. Pi by 2 is here. So this is the point which is pi by 2 comma 0. So the line will be passing through these 2 points. If the line passes through these 2 points, I hope I need not tell you, the graph of the line will be drawn like this. The graph of the line will be drawn like this. I'll just stretch it like this only. I hope you are able to understand it, although I am not able to bring it inside this entire board, but still it is perfectly making a great sense. Because see, I hope you are understanding, this graph will be going upward and this line will be going there. So it will be making an intersection somewhere above the board, which is not in my range to draw, but I hope you are able to understand this, that this graph will be going up. I hope you can see this, and this line will be intersecting with this graph. So that will be one point. This will be the second point. This here is the third point. This here is the fourth point, and this here is the fifth point. I hope I did not make you understand that how did I get these 5 points. I hope 5, right? Yes. First, second, third, fourth, and fifth is also there, but I cannot draw it. Let's say the straight line and they intersect here, somewhere here. But that is not in my range because the space is limited over here. But if I had continued it here, between minus 2 pi to 2 pi, these two graphs are intersecting at 5 points. So these 5 points of intersection would be the solutions here. Did you get this part? I hope we did nothing, but we simply draw the graphs, and through the graphs only I could finally find the solution. Did you understand this particular part? Now with that, I hope you have gotten a great clarity on trigonometric equations. And of course, along with this, we have discussed a lot of formulae, a lot of identities. My only request will be that you learn all the identities. Take a note of all the identities, whatever we have discussed in this session. Of course, we will provide you these short notes. Through this also, you can maintain the list of those identities. But do keep these identities with you. Take a good note of it. Revise them every day, like you know the way doctor prescribes us the medicines. You paste that entire list of identities in front of your study table and revise it every day, in the morning, in the afternoon, in the evening. That is the only way through which you can actually memorize them. I am strongly against memorizing or mugging up things, but yes, at this stage, there is no substitute. Yes, you can learn or master formulae through practicing, and they can be there at your fingertips. But at this stage, when we are left with so less limited time, please understand that learning them, memorizing them is the only way we have here. Because trigonometry is used with some other chapters as well, and without having these identities, you cannot solve those questions. So if you are saying no, trigonometry can be skipped, we can get marks with the help of some other chapters if we are not able to learn these identities. No, this is the chapter which is used with other chapters. So let's say you are bragging on the basis of integration, that you are good at integration and then you will be able to solve questions on integration. No, you cannot. To solve questions of integration, you should be good at trigo. And trigo is used in some other chapters as well. So learn the identities. They will be used. IIT will ensure that it is asked. All the concepts are asked. So whatever we have discussed in this one shot, I think you have understood in a very great detail. And all of this we are giving or providing to you at absolutely no cost, at absolutely free of cost. And with these one shots, we are also giving you the notes, the DPPs, the real-time environment practice we are giving you. You can click on the link given in the description. It will redirect to our PW app, from where you can practice it in the real-time environment. The way you are going to attempt your actual examination, the real JEE exam. In that same format, we are providing you the DPPs so that you can get the real environment practice scenario, real testing scenario, and you can get used to it at absolutely no cost, at absolutely free of cost. Are you understanding that? And yes, PW is an amazing platform from where millions of students are already preparing for different competitive exams. With that, I think it is sufficient for the day. Let us call it a day here. Thank you so much. You have been a great audience.